No, it's not. Okay. Just checking the level. Okay, I got the audio at a good level, I think. Okay. Sure. I'm making a note card to study from. Or something. Words. Okay. Oh, let's not put that back to rectangle, then deselect it. Okay, cool. So, for this test, we get a 4x5 note card that we can write anything we want on. And I want to figure out what to put on it. So, I don't even know where to really start here. Just looking through my notebook, because we went over yesterday everything that is going to be tested. I want to figure out what's the most important stuff. Oh, you know, I want to write down our definition of analytic. That will be a good start. Because I think we're going to start out writing important theorems, and then we're just going to put as many example problems as we can. Sure. I'm debating if I should get the definition of analytic from my notebook, or if I should, I feel like I should look in this bad boy. There's no bookmarks, are there? Nope. I enjoy having bookmarks. I don't enjoy not having them. Wow. Fourier integral theorem is in the first chapter? Holy crap, I didn't even notice that. Joseph, congrats. Hope you're doing well. Ooh, ha. These bad boys would be a good idea to write, because I always forget them. They're not that hard to derive, but like, why would you waste your time doing that on a final when you can just, they're really easy to write down. Calculator is making my brain explode? Why is that? 8 IKJ. You have a math exam next Friday? Good luck. I've got a math exam on Monday. Okay, write it teeny tiny. I already forgot what the kosher Riemann equation. Du dx. Actually, we'll use u sub x equals v sub y. That's even more compact. Then it'll be u sub y equals minus v sub x. Dude, I feel like I feel like you should be able to come up with some type of mnemonic to remember this. Uxv. Oi. No, I don't know. I'd rather deal with abstraction than these real world numbers. You really are falling into the topology pit, aren't you? I mean, that's a shame to hear that you think calculus is boring. Calculus is a class that made me actually like math, but of course it's not for everyone. I don't blame you, especially if your teacher isn't good. The number one tip for calculus I can give you is to use this website to learn from. Paul's online notes. It goes over pretty much everything you would encounter in a typical calculus class, and he provides really good example problems, especially. So if you're ever struggling with the concept that's being taught in class, just look at Paul's explanation of it, and it'll probably make more sense. The other website that, if you're not already aware of, you should be, is Wolfram Alpha. This is basically a calculator that can handle most any calculus problem you want if you know how to type it in. So like if you want to find like if you're being told to find the extreme points of a function, you can literally just say extreme points, and then let's just say x sine of maybe we can do sine of x and see what happens. Yeah, so it'll give you like local mins and maxes. This one I should have given a better example where it's not approximating. Let me do like 4x cubed minus 2x squared plus x minus 1. Excuse me. Oh, because it's a cubic? But there should be... Freaking... Okay. Apparently, I don't know how to ask Wolfram Alpha. Like the correct way of finding this, but it does know how to do it. There we go. I gave it one with complex. Wow, I gave it a bad example for a cubic. Make it epsilon delta so it isn't boring. Oh my god, that's the opposite. Epsilon delta is the worst. Well, yeah, I just chose a bad cubic, but the point stands. It knows how to do calculus, so it's really nice for checking your work. Okay, so I hope that helps 8IK. This song kind of sucks. Where are we defining? Oh, okay, here we go. Those look like cells. What looks like cells? These? These are contours in the complex plane. Wow, that's some good LaTeX right there. Oh no. Something went wrong. This doesn't actually have anything to do with cells, but I did make something that looks like it could be cells. I need to let it go for longer, but like I don't know, this looks like it could be like a petri dish. This is actually like two fluids separating from each other. And this is like the initial condition that I'm giving it. It doesn't look anything like how it's supposed to be, but as soon as the actual equation runs. Yeah, and then the homework thing I was just working on for this class, we got a pretty cool looking visualization from the reaction diffusion equations. It's like hypnotizing. There's actually the solution to a PDE. Oh yeah, 8IK. I wouldn't feel bad about that. This is graduate level math. So you shouldn't expect yourself to just understand this just by like looking at it briefly. Jed, you're under my command now. Yeah, I kind of wanted to play with that one and like try some different color schemes just so I can make anything that's like cooler looking. Also, let it run for longer. But that'll be like a bonus thing if I can get through this studying. What I wanted to get was the definition of analytic. That's not a definition of analytic. Oh God. Good luck with that one too. 8 IK. Sometimes your brain just needs a break. Like, if all you've been doing is studying, it can be better to just take a break and rest than it is to study every waking hour. Okay, I'm going to take the definition of analytic from the notebook. So I don't like this one. And I don't mean from the movie, The Notebook. I mean from my notebook. Although maybe in the notebook they also talk about analytic functions. I wouldn't know. Singularities. Geometric series. Cauchy's theorem. We're getting there. Cauchy-Riemann. Did we do this before Cauchy-Riemann? Where is... Here we go. This is in the third lecture we covered. Analytic functions. Break is supposed to be 30 minutes long. It's been 6 hours. Oh no. Speaking of a break, I picked up new to me game this past weekend. Yeah, what game is it? I have that in my library? I don't mean to have it. I don't think I bought that. Islands of Insight. I do have it. Is it free? I don't think I bought this. Wow, it's $30 right now. Cancel the John out with the other John. What are you talking about, kangaroo? I know that Talos played it, and I think Talos enjoyed it. I have not actually played it though. I didn't even know that I had it in my library. Fair enough, kangaroo. Welcome in. Yeah, that's what it reminded me of. I think that's why Talos is playing it. All right, 8 IK. Good luck. That yeah, if it was free at one point, I probably have it in my library because I saw Talos playing it. Okay. So I'm taking the definition of analytic from my notebook. And I'm going to paraphrase it. Analytic. At point z naught if differentiable. I already messed up. Okay. Well, I didn't really mess up. It's just, it makes, okay. It's differentiable and single valued, but it makes more sense if you say the word single valued before differentiable. At z naught and each point in a neighborhood of z naught. Okay. So yeah, well, this is right here. It's kind of my template for basically the index card that we're allowed to bring into the exam with whatever notes we want on it. Well, it's not really an index card. He said a 4x5 card, which index cards are 3x5. So I'm gonna, I guess, take that extra inch, that's what she said, and run with it. Index cards are also 4x6? Really? Oh, the index cards that I have are 3x5. But either way, that neither of those are 4x5, which is what he said we could use. So I was planning to just cut it out on a piece of binder paper. This is my approximation for what 4x5 inches would be on a Journal++ page. I counted out the squares in this grid. And this looks about right, because this should be 8.5. Oh, it's 8.5 by... Oh, shoot. I thought it was 8 by 11, but it's 8.5 by 11, isn't it? Ugh. It's fine. Let's get 2x3. That's a small index card. Either way, we'll use this as a template, and then I'm going to physically write it down sometime off stream, and I'll fit whatever I can fit. Okay, so that's analyticity. Let me go back in my... Wow, I went to the exact right page. Multi-valued functions. F prime z is path independent if it's analytic, because the limit needs to exist in all directions. The integral of f is also path independent. They satisfy Laplace's equation. Yeah. Yada, yada, yada. That might be a good thing to write down, because I always forget that that's true. And it sometimes is helpful. Analytic f of z equals... If you can write this function of a complex number as u plus iv, then you know that u and v, which are functions of x and y, independently satisfy Laplace's equation, which is sometimes helpful. Hey, Goofy. How's it going? Tommy, hello. No, I'm working on a master's. Um, and I'm a crazy person who signed up for the PhD level class. Um, so this particular class that I'm studying for right now is like their PhD level complex analysis. For anyone who doesn't know, Tommy is a philosophy streamer. Normally playing PUBG, but also just talking about philosophy and stuff. Uh, I know of him through Shane's little. I forget what he even called it, but he had a bunch of his friends come on and talk through like what they do on a stream. No worries. Cannot wait till I'm done with masters and the PhD to go look at employment at CERN. That's sick, Goofy. Holy crap. I forget if it's CERN or Kern for how you pronounce. I think it's CERN. What are you studying, Goofy? I'm sorry that I forgot if you told me. That's what I thought. I didn't know master's level math classes had exams. Oh, this one sure does. Yeah, same. I think it didn't have much of an official name for it. Cutting edge of physics, very fun. Astrophysics? That's awesome. Good luck with that, Goofy. Do you have a particular focus within astrophysics yet? But yeah, so my other classes are just like normal master's classes. Both of those just have projects instead of exams. I'd almost rather do an exam though, because the projects are just being like real pains in the ass. Theoretical? Okay, awesome. Theoretical physics and quantum mechanics. Astrophysics and oh my god, you're doing everything, Goofy. I like playing with colorful shapes like rectangles and triangles, sometimes circles. Hey, that's just as valid, Jed. It's no better or worse than what I'm doing. You hate exams, both taking and giving / grading. I never had to grade exams, so maybe that would change my opinion on it. But like the main one that's being a pain in the ass is I'm in a class called Computational Models in Biology, which is about just the intersection of math and biology. And that's a group project. And it's just I've spent more like than a week straight just working only on that and trying to get things done for it, and I have very little to show for it. So that's been the main reason why I'd rather just take a test, because it's like we have to take an academic paper that uses biology and math in some way and like do the next step in that paper, like wherever the authors left off, you pick it up, and it's been just a huge thing. Which if you on huge versus normal crayons. Both are delicious, but the huge ones are more filling. That's some good insight, Jed. Path of least action seems very fun or interesting. Yes. I remember. Is that the exact thing that I learned about? Because I had a little phase where I was studying general relativity. It didn't go too great, but that like because it's really hard. But I do remember learning about that. Um, you only touch relativity principles really at the quantum level. That, I mean, that's still pretty wild. Like, general relativity and quantum relativity are not the same, really. Okay. Yeah, I'm very ignorant of like higher level physics, even like low level physics. You're not related to any generals? I'm sorry, Jed. Um, Mouse. I'm sorry. I really need to study for this test. Fourier and ODE. Like, yeah, I'm sorry. I just it if I knew your question was gonna be quick, I would do it, but I have a feeling it's not gonna be quick. Uh, which is why I'm hesitating to like say yes here. Like less than 10 minutes. If you like, okay, just like put your question there, and I can always say yes or no, I guess. Or at least one of them. And sorry, Mouse. Like like my last due date is on Wednesday. So after Wednesday, I'm going to be a free person, and I won't say no to questions like I have been. But I'm just really buried in stuff, and it was hard enough to even do a stream today. Mohammed, I'm also doing grad school physics. My work is going to be on computationally simulating superconductors, which is a mess. That sounds awesome, though, if you can get it to work. As someone who's also struggling with computationally simulating a biology thing right now, I somewhat feel that pain. Your sounds a lot harder. Been distracting with bad though clever jokes. For being too much of a distraction, say the word. I'll throw this thing into emote only mode. Oh no, it's okay. All right, sorry, Mouse. I always feel terrible saying no to doing questions, but it's just grad school's been another level of work. My teacher actually for this class, I don't know what he based it on, but he did claim that the applied math department generally has the most labor intensive classes out of the university. So that was kind of fun to hear at the end of the quarter. Before I, accepted the application offer. Or after I accepted the application offer. One thing I learned, streaming my rating, I'll be distracted 80% of the time. It'll take me 4 times longer. Yeah, Tommy. I definitely am not expecting to get as much done right now as I would do if I was off stream, but I haven't streamed in a week. Like I didn't like I streamed on Thanksgiving to do a cooking stream, and that's the last time that I streamed. So that just felt like too long, but between streams already. Daniel-san? That's true, Jed. Breathing is important. I assume that's a quote though, and that I'm not picking up that quote. You'd have to understand how waves permeate through space-time at the quantum level to apply to more complex situations. Wow. That sounds really cool, Goofy, though. If you don't know Fizzbuzz, I feel like you would actually... Damn it. I don't know if you heard that. I just knocked my Rubik's Cubes off my desk. If you don't know Fizzbuzz, I feel like you would love... Like, I love hearing about it, but I think that Fizzbuzz especially would also love to hear about it. He's both really good at physics, and he loves making, like, simulations and visualizations. Karate Kid, right. That's why he said Daniel. Why am I wearing a winter coat inside? Because I'm very cheap and I don't want to turn on my heater during the day. Right now it's 46 degrees outside. So I used to have a blanket that I would wear over my shoulders, but I decided to switch it up and go with a coat. Actually, I'm not only wearing a winter coat, I'm wearing a hoodie and then a t-shirt. I am layered up. Coach, how's it going, dude? Freezing my nadgers off, but not terrible. Same. Oh yeah, links are turned on in chat. You can post away. I need this. Oh my god. That is hilarious. Oh my god, this is Photoshop too. Or at least her face looks so Photoshopped into this. Oh, that's hilarious though. A math like Snuggie. Coach, I've been slacking on saying hi in your stream, but I hope that that's been going well for you. Are we talking about the blanket or the thing in the blanket? Yeah, I could use both a blanket and a woman. I don't. I think you can only buy the blanket at Walmart though. Unfortunately. Hey Slim. Did I know the Mararoni penguin not only has a delicious name, but they also find a mate for life? Mararoni? Like, is it delicious because it sounds like macaroni? I almost said macaroni penguin. These are also for macaroni. Oh no, okay, it is macaroni. Oh my god, who does this remind me of? Like this is almost like I was about to say Guy Fieri because of the frosted tips, but honestly, I'm kind of going more towards like Goku now, or something. Both will keep you warm. Legally, yeah. VR gaming. Hey, I'm good. How about you? She looks like she knows what she's wearing. Not yeah. Pen from Neon Genesis. Is that an anime? I have not seen that. Oh, speaking of Slim, I announced this on the Discord, but this is a good opportunity to announce it on stream. Ugh. Ooh. Sometime we're keeping the date flexible, but sometime in like 2 weeks, Slim and I and anyone who wants to can talk about this book, Thinking About Mathematics, The Philosophy of Mathematics by Stuart Shapiro. Wow, that lighting got really weird there for a second. But yeah, it just seemed like an interesting book. And I'm going to do my best to read as much as I can of it by the time that we have that. The language, I'm not very deep in right now. The language is kind of dense, so I need to like look things up for what they mean and like really think about the sentences. But I think it's going to be a cool read. It is an anime? Okay. Slim is getting slimmer for Christmas. Yes, I did. So I also thanks to Slim, I realized that my university has a dedicated mathematics research library that had this book. And like you predicted, I'm able to keep it until like February or something. Like it's a really generous due date. But yeah, I had no idea that we had like a dedicated like math library here. Hey, syntax error. You ever say that macaroni penguin was named by sailors after macaroni fashion, which is popular at the time? What is macaroni fashion? that have anything to do with macaroni art? I've got a hairline better than than BR Gaming's math teacher? That is hard to believe. I my widow's peak is doing a lot of work in hiding my hairline, but it if there's a battle happening on my scalp, the battle line is slowly moving back. Oh, the penguin. Never mind. Okay, yeah. I see. Okay, I get the joke now. BR Gaming, my bad. Whoa. What the hell? This is like he's wearing a hat too. It's like Marge Simpson level hair. So the macaroni Batman hero comes from? I never heard of that one. Then the macaroni from Batman is based on that. Except the R's have consumed 3 Red Bulls. Oh my god. Remember that time you were studying for a test and ended up looking at photos of penguins in 18th century fashion? But you know, I feel like I'm still learning things. So, you know, this is a form of studying. Who is known as the macaroni artist. Oh my god. But did anyone actually have hair like this? Like, that's not possible. That, oh my god, there's a lot going on with this. I think I'm more of a Ludwig balding than Nortwood balding. Ludwig, okay, I know Ludwig is a really big streamer, right? But I don't know what he looks like. I don't know who Nortwood is. '18+ hairstyle. Not the streamer? Oh. The composer? I think there's a composer named Ludwig. But oh, Beethoven. Yeah. Okay, yeah. This is Batman's macaroni. Oh my god. True, Slim. This is macaroni fashion. I didn't know this Batman character existed. He even has the hat. The hat is the most ridiculous part of this. Now you know the context in the exam question is the convex of 18th century British man's wig. It's You know, that's not far off, Tommy. BBR Gaming, what games do I play? Right now it's mostly Daisy. I need to get back to I've nearly beaten Sifu. I haven't touched that game in a few months though. I think I'm gonna get back into old school RuneScape soon. I want to get back into Factorio, but right now I've hardly been gaming at all the last few weeks because of school. But the main game that I've been putting my time into is Daisy. Fiona is way prettier. True. Receding hairline versus splitting hairline. Male pattern balding versus female pattern balding. Okay, wait. If I Google female pattern balding, I'm gonna hide the screen just in case something weird comes up. But oh, okay. Like that. I honestly, I don't know if I've even heard that. Oh wait, there's an actual, is that the Ludwig scale? Do these have names? Like, have we quantified balding? That's the Sinclair scale. Wow, what the hell? You can be like a level 5 baldy? I didn't know that there were actual like scales. I'm bro balding 0.45 Ludwigs a week. True. Yours are seating and splitting. Okay, yeah, BR gaming. That makes sense. Okay. It turns out that the wearing a winter coat indoors kind of gets hot after long enough. Maybe we'll just unzip. Okay, but like, I'll, I, I, if I went bald, I would just like take the hit, and at some point, I just like resign myself that I'll eventually have to just start shaving my hair. Um, but like Rogaine and stuff like that, like it just has crazy side effects, doesn't it? Like I don't really trust baldness medicine. Rotational motion is straight up hell. It is. It's so hard. I'm bald. My balls have more hair. Well, hey, if you ever get a transplant, a hair transplant, you know where to take it from. For the next flight to Turkey, that's where it happens. That's where it goes down. $2K plus? Yeah, I'm sure it's not cheap. I mean, at least I'm sure it's a lot cheaper in Turkey than it is in America. Okay, you know what? I think the amount of yapping that I'm doing is making me heat up, evidently. I shaved my belly last year because of my abs. Ooh, wait. Do you work out? Yeah, for the curly ones on the head. Yeah. You have a six pack? Damn, Mouse. Okay. Who said that nerds can't be buff? You said that? Okay, the next thing we should find is Cauchy's theorem. Oh, hey, found it. That was easy. You have a single pack? Same. You know, in a way, I have a 12 pack. It's just cans of beer in my fridge. It took 6 months for the hair there to grow. I'm trying to think. I do occasionally like trim down like my like chest hair and like belly hair. That's probably about every 6 months. Just, you know, I enjoy keeping a tight ship. Can lift 3 times my weight? Oh my god. That's impressive. I meant to start working out when I started up grad school, but it didn't really happen because I got busy doing homework. We got an ant in here. True. Stream's going somewhere personal by shaving? Yeah, let's all share our shaving habits. Does anyone do any like styles? Or do they shave it any shapes into their body hair? 200 kg, 440 pounds? Wow, is that like squatting or benching or what? You can't divide 200 by 3, so I'll never know your weight. You got a mullet? Oh no. I had sort of a mullet in high school. It wasn't good. Simple closed curve. Let f of z be analytic over some region D. Okay. So let's paraphrase this. Cauchy's theorem. F of z. Should I abbreviate analytic as anal? That sounds kind of funny. And it's anal indeed. And C, simple. Wait, is it simple and closed? Yeah. Squat and deadlift because bench is hard for you. Okay, yeah, that's impressive, Mouse. BR Game is making us jealous. Never in my life have I shaved down there. I mean, you do you. I'm not a fan of the jungle. You abbreviate it like that syntax? Hell yeah. Simple closed curve contained in D. Then the closed integral around C is 0. Nurse shaved me down there. I guess I wouldn't know. Maybe that is some amazing experience. After shaving, it feels like hell there for a straight week. Now Poison Mouse is making me jealous. The grass is always greener. You have an amusing story about shaving it. It's too long to fit in this margin. Next time on your stream, Slim, I guess. A shaving stream instead of a cooking stream? Yeah, let's see how long that one lasts on Twitch. I mean, I could legit do a beard trimming stream. I think it'd be kind of boring, but I do trim my beard every Sunday. I can't imagine. I mean, I have seen shirtless dudes on Twitch, like even on the front page. So I think you're allowed to be shirtless. Do a buzz becoming a true routine. I might pass on that suggestion, BR Gaming, but I do appreciate it. Playing with Tourette's? I don't know what that means. I know, yeah, Twitch has weird enforcement of their rules. Zach, thank you so much for the raid. Hey, Ivan. Hope you're doing well. You all stepped into a bit of a weird conversation, but I was lurking on your stream. I hope that the tier list went well. Hey, K-Pars. I'm the killer rap, right? Yeah. For anyone who's here on my end, check out Zach, aka Eats a Toy Pie, awesome math streamer. Trying to roll the R's. Kill. Oh my god, it's so hard to do it after an L. kill, kill. I can't roll my R's after an L apparently. Rabbit, killer. That why is that so hard? That really confuses me. Killer. I don't know. Oh God, mouse. I don't imagine Zach is gonna go there. Think the movie rolls the R's? Do they? I don't remember. It's been too long. There are those who call me Tim. They read at the wrong time. Yeah. So yeah, what's supposed to be happening here at least is I have a final exam for my complex analysis class on Monday. And in that exam, we're allowed to bring in, for some reason, a 4x5 note card, front and back. I say for some reason because usually index cards are 3x5, right? But I don't know. And so I am figuring out what I want to put on this note card, and that's what's happening here. Unto 3, thou shalt not count, right? 4 is too many. 5 is right out. Welcome in. Oh, we have another mouse here. CZAUS mouse, Oz mouse. The class uses, allegedly our primary book is this one right here, but the class makes reference also to two other books pretty frequently. This is one that we've been following, maybe potentially the closest. They're multiplying. This one I'm looking through here is an unpublished book that the professor wrote. So I don't know if you can even like find this generally on the internet, but it's just like a really brief applied complex analysis book. Oh, that's funny. In class, he'd always talk about for certain problems, just refuse to do them because they're ill-defined, and he actually uses that same phrase in his book. But yeah, so this is one that we're like primarily following, but there's kind of like a lot of like departures too, I guess. Currently learning about literally nothing interesting because yeah, that's what happens in high school. Sorry, Lucas. Well, once you get to university, you get to like specialize at least. Can't wait for Christmas. Christmas is awesome. And just because I like to show off to people, I guess. For a different class, I just made some visualizations for solutions to what's called the reaction diffusion equation, which can model. I think in this case we're using it to model how, like, if you have two different chemicals in some like area, how they spread and react with each other throughout that area, and you get stuff like this. So, you know, you get hypnotized by reaction diffusion, I guess. I want to let this run for longer and see how it behaves, like, for longer time. I'm also working on one for that can model how two fluids will separate from each other. I need to let this one run for longer too, but you see, like, the red and the blue are slowly like separating from each other. Don't mind the very first frame being different. Maybe the coolest thing I've done for this class is simulate vortexes like hurricanes, though. And since it's a computer simulation, you can set up all sorts of crazy starting circumstances. So in this one, I have 4 hurricanes like right next to each other. And if you just let the simulation run, you get this pretty thing. How's the homework going? There's been a lot of distractions, which is welcome though, because whenever I turn the stream on, I know the distractions are going to happen. It's going okay though. I'm really overwhelmed with the amount of work that's on my plate, but I at least have something that I could stream today, which is the setting for the complex analysis stuff. The other stuff I'm doing, it's really difficult to stream it. Let me catch up with chat here. It's my favorite holiday movie. That's a good question. My answer to it used to be Elf, and I still really like Elf. Hey Star SK, good luck with your test. All right, see ya, BR Gaming. Good luck with your organic chem. A Christmas Story is really high up there too. I'd have a hard time choosing between those, I think. Femlox fan, I remember you had a question about Bayes formula in Ivan's chat the other day. How we would know the terms of denominator, and I think medical testing is a good example. Oh, nice. Yeah, I just watched 3 Blue, 1 Brown's video on Bayes formula. It's pretty good, but I wasn't paying as much attention as I should have, so there are some things that I kind of missed there. Alright, this is about coding. I was so fucked because my entire code didn't work. Then after the test, someone told me I forgot to put between a variable b at like 3 stops. Oh, like it was just a really small mistake. Dude, for this code in particular, I've had the right answer for a week, but the thing that has been driving me crazy and is like like causing me so much stress is that like their solution, the answers come in a particular, like the numerical values come in a particular order. So like they have an autograder that checks what values are stored in these variables, and they need to match nearly exactly. I've had the right answer for over a week, but I kept getting marked wrong because I organized my value differently. So I had the right numbers, they were just in a different order. That's also completely fine, but it didn't happen to match the order that they did it in. So I've had to go to office hours multiple times just to figure out what's the right order, and eventually I got it, but like it's so annoying. Like critical states, maybe K-pars, I don't know. Was kind of a heart saver. 7 watch streak, thank you. They did a new Christmas Story like 2 years ago. Oh, I feel like they did. I don't know. I don't think I saw it. It's like a grown-up, like a Ralphie's has grown-up one. A Christmas Story. There's a Christmas Story 2. Wait. 2022? A Christmas Story Christmas. God damn it. My Rubik's Cube just fell again because my notebook is resting on it. I have not seen this. Peter Billingsley, Julie Haggerty, Zach Ward. I don't recognize these names. Peter Billingsley. Bring me to IMDb. What have you been in? Wait, is this? Was he also the kid actor? Oh, that's so cool. They got the same actor. He was in Spider-Man Far From Home? In Iron Man? Who was he? Oh, he's a producer. But he was a character in Spider-Man. Huh. Yaya Che, I'm currently in progress for my master's. I'm almost at the end of my first quarter. I think the kid wanted a video game console or something. That makes sense. Check it out. Sounds interesting. Been helping a friend study for the first X-ray exam. Oh, Bayes' theorem makes sense. Yeah, for that. I have master's in applied math. Yeah, Che. Isn't there like a mathematical theory that something is like unpredictable? I thought it was named three. Yeah, there's the three body problem in math. It has to do with we know a lot about how two things orbit each other, like the Earth and the Sun. But if you suddenly throw three things into that, it gets really chaotic. And we're not able to get a clean formula for how they're going to move. We can simulate it and get an approximate solution, but we don't know how to actually solve it, I think is the thing about the three-body problem. I'm getting just like about the Netflix series, though, because that was a popular series. But yeah, I haven't actually watched that. Hey, Famished. But yeah, it comes from like, it's a set of differential equations that we don't know how to solve. Well, they can't really be solved. Maybe it's a better way. Yeah, no general closed form solution. When you did your cooking stream, was the camera connected to your laptop or was it a Wi-Fi camera? It was. My phone camera. God, my other Rubik's Cube just fell. Okay, these things, they lost their desk privileges. I'm gonna put them over here. See, these are equations here. It was my phone that on my phone I go to the website video.ninja. I give them permission to see my camera and they give me a URL that I plug into OBS. And that's how I do the cooking streams. So my phone camera gets sent over Wi-Fi to my computer. Isn't everything on first hand unpredictable when you put three things instead of two? It depends on the things. Not necessarily. If you have three like neurons that are linked, you can predict how those will behave. Well, actually, that might be a bad example because you might not be able to solve those equations either. Just because there's three things doesn't mean you can't solve it inherently. It depends on how the equations look. Usually, the more complex it gets, the less likely you're able to solve it, though. You want to read the books before season 2? Nice. Yeah, analytically. Oh, do you use it too? Yeah, it's really nice. Like everything else I was looking into for getting iPhones to be fed into OBS costs money. You can start numerically and get a unique solution. Oh, that's cool, K-Pars. It's a physics problem. I'd say there's also mathematical interest, though. The deeper I've gone into studying applied math, the more it intersects with physics. It's not just physics, but like a lot of things that I'm learning, you could also call them physics. Parameter function? Quintic roots? That would make sense. I'm not sure what you mean by a parameter function. But yeah, so like in advanced like math, one of the ways that you can specialize is in something called partial differential equations. And so like a really important one is, say, Laplace's equation or the heat equation. And these are both really physical things too. Like they're of great mathematical interest, but they also directly have physical interpretations too, and physicists also really care about them. Using Video Ninja to set up my pod. I didn't know that you had a podcast. Unlike Zoom, you can have video calls there for free as long as you want. Oh, nice. Shout out physics, yeah. The parameter function is basically a three-dimensional function for a two-dimensional function, which is the same as a three-body problem. Oh. Sort of. I think that's different, though. Like a function that has a parameter is sort of three variables, but not. So I see what you mean there. It does have parameters in it, to be fair. Yeah, I guess that they are parameter. Yeah. It's fair to call them parameter functions, but it's not the thing that makes it difficult to solve. Okay, so we did Cauchy's theorem. What's next? Okay, yes. We have another note on Cauchy's theorem that I want to include here. A contour C. Oh God. Can be deformed into another contour CR, because why not? If orientation is same and no singularities between. Oh, the word between is important. But if there are singularities, you can actually fix it. You're not lost. Then the integral around CR is equal to the integral around C plus 2 pi I sum of residues. I had 2 podcasts. One in English, Smart People Getting Drunk. Nice. I target people to do the podcast. Only had like 5 episodes. A Spanish podcast that has over 50 episodes. Oh, cool. A magnifying glass? No. Funny enough, they did say to bring a stapler. Because they said they prefer us if we bring those like blue books that are just like scratch paper used for tests, but you don't have to. And so I'm planning to just bring my own, like tear out some sheets of paper from this notebook here. And you have to staple those. I do have a stapler, so I'm just going to bring that, I guess. But I thought it was kind of a funny thing to tell students to bring their own stapler. Smart People Getting Drunk is a great premise for a podcast. Okay, next I want to write down the residue theorem, but not just any residue theorem. I want the generalized residue theorem, not the kernelized. The generalized. Where is it? Hannah Fry and Vsauce. I don't know who Hannah Fry is. Vsauce, I know the name. I don't remember what they do there. The Rizzler. If I am, it's gonna be difficult for me to do too many help questions because this is just a really bad time for me, unfortunately. If you do need help though, someone who will be streaming is actual education. He would definitely be able to help you out. So the second person in that list there. I normally do math help on my stream. I feel bad. I feel really bad about it. I hardly have time to not work on homework the last few weeks. So rather than not stream at all, I figured I should at least stream some studying. British mathematician who worked in fluid mechanics before becoming psychom. Oh, that's cool. I was gonna go to grad school for stats/math, and our glorious leader cut the funding, so I'll no longer be. Oh, that's. I'm so sorry about that, Peachy Risu. That's really tough. If you want to give me one geometry question, Rizzler, I can look at it. But like I said, I don't really have that much time right now. I'm learning more and quicker than I would have if I was in school right now. Makes me wonder why grad school even exists. Yeah, I mean, I think that's an uphill battle, Peachy Risu, to convince people that you do know your stuff, but you can do it. All right, Rizzler. Yeah, I'm sorry. I hate saying no to people who ask for help. It's just a necessity of where I'm at in life right now. Here it is. Wait, you spelled it right? What? You corrected not a typo with a typo? But yeah, no, focus on your cooking. I get it. Okay, that's not a G. Generalized residue theorem. If f of z has only poles inside C and simple pole on C, then the principal value, shouldn't this be a closed? I wonder why it's, there's no circle there, but I feel like there should be one there. Maybe not. F of z dz is equal to 2 pi I sum of residue in F, wait, in C, plus pi I sum of residue on C. Just vibing so hard with algebra/probability. Just apply for next year. Ooh, yeah, I mean, those are cool fields. They're not my thing, but those both have a lot of depth. I bet there's a good amount of crossover too. Okay, so that's the generalized residue theorem. No point writing the regular residue theorem. And I do have a sample final exam that I was planning to do once I finish this. So now we're going to start writing stuff down about integrals. Evaluating real integrals using complex variables. Most grad level stats uses linear algebra for describing equations because it's a natural way to represent data sets. That makes sense. I imagine when someone says probability, though, that's good. That's a different thing than stats. We're related, but I imagine they are going to have a different emphasis. Hey, Skirtle. Hope we're doing good. It's Jordan's Ligma. Studying, yep. I'm figuring out what I want to put on little note cards that we're allowed to bring into the final for one of my classes. Somewhat very yeah, I agree with that. I need a bookmarker. That will do as a bookmarker. It's a notebook marker. Okay, so if we have an integral, oh, speaking of A Christmas Story, Quinter, thank you so much for the Prime, dude. I hope you're doing well. 4 months. What a Chad. Dude, I really miss playing Repo and Daisy with you guys. But after next Wednesday, I'll be a free person for a few weeks, so I'll get to be a degen again. Like I gotta do things like show for any R value matrix A, show A prime A and A prime are singular positive. That, oh, nice, yeah, that makes sense for why you would want that. And dude, A prime A, like the a matrix times its transpose is just like a great thing in general. Don't want me to take more linear/linear model courses for that program that were heavily proof based. I mean, linear algebra sells a lot of proofs, but fair enough. What do you have when you have a lawyer buried up to his neck in sand? Not enough sand. Yeah, that's not a fortune, Skirtle. You're right. Yeah, Quinter. A lot of stress as I'm trying to work on stuff, but I'm getting through it. Yeah, you did get scammed there, Skirtle. I've seen that one before too. That's a repeat. Is it good? More free time for contour integrals? Oh god, Fizzbuzz. I'm still scarred from that one that I was doing for like a few weeks ago from the solution to Laplace's equation. And it was completely avoidable too. And I never even actually did that contour integral. Thinking hella time at work? Okay, well, I'm glad our busy times are lining up, I guess. Work first, play later, yeah. Oh, and Fizzbuzz. I still need to check it with the professor for what exactly would count as a project. But I was looking again at that message she sent me with the PDs, and I think I want to do a project on Con Hilliard. I don't know if that's how you pronounce it, but like this is the thing that I quickly made just to see if I could do it, and I think it'll be like a cool thing to get visualizations from. So this is two fluids separating from each other, I think. I need to let it run for longer because it'll be even cooler if I let it run for more time. But yeah, that's how I pronounce it. Okay. Yeah, this one was actually it was really quick to put the simulation together. So I guess I'm actually learning something. But Fourier transforms are just a great way to numerically solve things. Design the perfect sauce? True. I wish I could figure out better initial condition though, because this just looks ugly. I can tune this a little bit, but yeah. Another joke? What's hard going in and soft and sticky coming out? Chewing gum. That's a good joke, Skirtle. I think you're being judgmental. I like that one. Do I use obsidian? I don't think so. When I hear obsidian, I first think of the company that made Fallout New Vegas. I second think of The Rock. I third think of Obsidian in Minecraft. So I don't know what Obsidian you're talking about. A good joke is my life? True. Yeah, I've been working on a playthrough of Fallout 2 for like 6 months now at least. Um, it's pretty fun, and they actually have I haven't gotten there yet, but there's San Francisco in that game, and I'm excited to see that. Right now I'm in Reno, and they have like um there's an actual like porn set, and you can be a fluffer there. So I and of course I said yes. Should we Fallout 76? Honestly, I would. I think they just updated it too because of the Fallout TV show. I enjoy Fallout 76. I haven't played it in a minute. I'd be down to start up a new character though. Obsidian is a naturally occurring volcanic glass formed when lava extruded from a volcano cools rapidly with minimal crystal growth. It's an igneous rock. Produced from felsic lava. I don't know what that is. Obsidian is rich in the lighter elements such as silicon, oxygen, aluminum, sodium, potassium, commonly found within the margins of rhyolitic lava flows known as obsidian flows. I want to know what those look like. Obsidian is a personal knowledge base and note-taking application that uses markdown files to help users organize and manage their thoughts and information. Oh, okay, that's probably more what you were asking about. Hey, Dexter Morgan. It allows for internal linking between notes and visualizes those connections. Okay, yeah, I have not used that. I've heard of similar programs, though. They're called like mind mapping. Maybe that's the name of a program, but like, it's just a way to like organize your things that you want to accomplish in life. Which I've never used one of those. I probably would benefit from it. I'm just a little bit lazy. I know that those programs really help people out, though. We can gooner human. I think I'm all gooner humaned out personally. You like organized notes and simplicity? Yeah. I I live and die by the reminders app on my iPhone. If I also I'll keep emails marked as unread if I still need to do something with them. Those are the two ways that I keep track of what I have to do in life. If it's not in one of those two things, I'm not going to remember it usually. You like updating says, oh, so you know what FizzBuzz. LaTeX rendering and Excalidraw. That is pretty sick. Okay, and so that's how this is what we do with an integral that is from minus infinity to infinity and does not contain an exponential to an imaginary. Well, yeah. If it's from 0 to infinity, we'll divide it by half and make it from minus infinity to infinity. If f of x is even, if it's not even, we're not being tested on that, so who cares? You use Habitica to keep track of what I need to do, because life is just a video game. Habitica, that sounds like a drug you would take when you're addicted to drugs and trying to get detoxed. Cold palms. You can ask the question. If I can't do it quickly though, I'm going to say no. And I hate saying no, but I'm just really busy with studying and trying to get this done. So it's difficult for me right now to answer many questions from chat, unfortunately. Normally, in any other case, I would always say yes, but this is just a really busy time in my life right now. Basic is there by default. Oh, nice. Living the good life. Look at us nerds doing math. It's all the coding and meetings and shit I need for work. Thank you, Cold Palms. Oh, you know what? If you need help though, check out Actual Education. He also streams on YouTube. He's the second person in that list. He might even be streaming today. Let me check. Oh, actually, no. He did a 24-hour stream. He's probably taking a rest. Okay. He's theoretically scheduled to stream in an hour and 15 minutes. I don't know if that's actually going to happen. But if he doesn't stream in an hour and 15 minutes, he will stream again on Sunday. Okay, so when you have some combination of trig functions integrated over 0 to 2 pi, I've never been quite clear on this, but it's the same thing as integrating over the unit circle in the complex plane for reasons that I don't quite understand. I guess it's because z is equal to I theta, but it's still kind of weird to me. Soap and education are not as sudden as a massacre, but they are more deadly in the long run. What? Why is soap deadly? Does Mark Twain not wash his hands? Third time it is the charm? I guess so. I don't quite know what that means. But also, if I'm getting a fortune cookie, I want like a Confucius quote or something. I feel like Mark, you shouldn't have a Western dude. I hungry. I might play some video games for a bit after I get food in my belly. Nice. I've seen people playing that game. It seems like it's all the rage. I don't know anything about it though. So cosine becomes z plus 1 over z over 2. Sine becomes z minus 1 over z over 2i. And then d theta becomes dz over iz. Participate in public shaming players get caught red-handed? Doing what? Okay, is this all I need to write about trig integrals, though? Now we need Jordan's ligma. Minus infinity to infinity e to the imz f of z dz is equal to the closed contour. If f of z goes to 0, as z goes to infinity, and m is positive. Okay, I'm glad I found my controller too, because I cannot play on keyboard for those types of games. Really? Roguesra, hey. Certain games you kind of have to use a controller for, but I grew up on keyboard and mouse, so that's what I'm like most comfortable with. Stealing and shit, you end up in a wooden cage, paraded around town. The person can throw veggies at you. That's hilarious. I love that. Bought a new PC controller on Amazon for under 13. Yeah, like the official branded Xbox controllers are pretty expensive. I think like in the realm of like $40 or something. But like I have the Power A brand or something and it's way cheaper. I don't know how. It's really nice for certain games, like Dark Souls is pretty unplayable without a good controller. Single player games in general are often nicer with a controller because you can just like sit back and relax. Roxera, I do. I'm rusty on it. I did take AP stats myself though, and I remember a fair amount about it. If you want, you can ask a question, but it's gonna have to be one, and it can't be too long of one, unfortunately. This is just a really busy time for me. After next Wednesday, I'm gonna have a lot more free time. But until then, I'm kind of a... Oh, you're curious? Okay, cool. Let me catch up with chat, and then I'll talk about that. I do love 8-bit controllers on PC. 8-bit do controllers. Is it like a brand? Last one I got was about $50. That was several years ago, starting to die a bit. Fair, yeah. Yeah, my previous Power controller started to get stick drift, I think, or something weird. Dark Souls is amazing, Famish. It's not for the faint of heart, but I love Dark Souls. Um, it's so good. So you're curious if you should take it next year. It'll be your 5th AP, so you don't know about the workload. Let me try and remember. So my senior year of high school, I did a lot of AP classes. I did AP Stats. I did AP Calc BC, AP Literature. I think 5 out of 6 were AP. What were they, though? I think my not AP one was computer science. That means I would have... Probably an AP history of some sort. I don't remember what the other one was. It was not that bad for me to handle it. And stats is a good thing to know just in life, I think. Like it as far as math classes go, that's a pretty practical one. It's like it's really good to know what a p-value actually is, because p-values are used all the time in research papers in like every field. Your lineup would be language, US history, bio, physics 1, and stats. You know what a p-value is? Yeah, I mean, they're gonna like the thing with AP stats is there's a lot of memorization. You're gonna learn about things like called z-tests, t-tests, chi-square tests. There's all these tests that they make you know, and there's a lot of word problems in interpreting words the right way, which is the main challenge of stats. I think the knowledge is good to have, though, personally. Which Dark Souls is good to play first? That's a good question. I would say either Dark Souls Remastered or Dark Souls 3 are the best ones to play first. Probably like Dark Souls 3, I think, is the strongest gameplay wise. So like, if you're only ever going to play one, I would say Dark Souls 3, I think. If you really like the Japan theme, go for Sekiro. Its gameplay is a little bit different. I really enjoy it. I actually prefer the combat in Sekiro to Dark Souls, but it is a little bit different. And I personally do not recommend Elden Ring to anyone, but a lot of people do like it. My system should handle Dark Souls fine. Oh yeah, especially like the older ones. I don't know what your system is like, but like I don't think the older ones are that bad on PCs. I played games that are called Souls-like and found them fun. Awesome. Yeah, it's a really steep learning curve. Like there's different degrees of Souls-likes, like in terms of how forgiving they are. Just with Dark Souls, go in expecting to die a lot and be okay with that. Like I just view every death as a learning experience, and so I don't mind it. It's pretty demoralizing the first time though. The first Dark Souls game I played was Dark Souls 2, and I put that game down for a few months and I came back to it. I didn't even get very far my first attempt, but eventually I really liked watching this one speedrunner of Dark Souls 2, and he's the one who like got me to pick it up again. Hardlocked. The tier 2 for 26 months or 27 months in a 26-month streak. Thank you so much, dude. I hope life is going well for you. Your family's good. I always love hearing from you. Dark Souls was released on September 22nd, 2011 in Japan, and October 2011 for other regions. Right, yeah. The way you would game on stream. It's fun. It adds like it. Gaming off stream doesn't quite feel the same. There's some games where I still prefer to do it off stream, but like Games like DayZ, it's nice to have chat to like talk to during the slow times. Um, I still remember watching Hardlocked back when he would stream. He was playing Essaker once. Well, he played Essaker a lot, but I still distinctly remember him setting up a bear trap, and he put it in a doorway, but he didn't realize that that was the only door out of the room he was in. So he was suddenly trapped in a room with just a bear trap blocking the doorway. And just seeing that like realization was really funny. I think it's technically possible to jump over them if you get it right, but it's really difficult. Okay, I got Jordan's lemma. Improper integrals. What am I saying about those? I think we're just going to write the example down. So the integral from minus infinity to infinity of sine of x over x. You would think that 0 is a problem with this integral, but it's actually not, because if you look at the power series for sine, the x cancels out. So this is a proper integral except for the infinities. That's a separate issue. However, well, I don't think anyone has. Conway's Game of Life is a zero-player game, as it's called. It is a really cool thing, but like all you really do with Conway's game is you set up the initial condition and then it plays itself. You're addicted to it. Is there like a website that like lets you set it up? Playgameoflife.com. Well, that makes sense. Okay, so this is. Ooh. Oh, this one dies out. This is a really cool thing to play around with. And so the cool thing about Conway's Game of Life is depending on the initial, like on this setup here, you can get all sorts of crazy behavior. If you don't know what you're doing, it's often just going to die out. But if you do it just right, you get these patterns that come up and they never die out. This one, it might die out. I'm not sure. Oh, oh, that's so cool. It got to a stable state. Okay, yeah, I can see how you'd be addicted to this. It's kind of fun to mess with that. Yeah, there's some really cool patterns that you can get with this. I assume the Wikipedia page will have some. Yeah. A single Gosper's glider gun creating gliders. That's a lot of G's. That's cool. They're like bouncing off each other and shooting off little gliders. Pupper type breeder red that leaves glider guns green in its wake, which in turn creates gliders blue. The hell? Dude, zoom in. Wikipedia actually has it. What? I never seen an interactive Wikipedia like module like this. That's so cool. Whoa! It's exploding. Oh, that's so cool. These ones are rotating? Dude, this is so cool. Oh my god, famished. I almost wish you didn't show me this because this is actually like too cool. I didn't realize that makes sense that Veritasium has a website. I didn't know that he did though. Forest fire model? Ooh. Is this interactive or is it just going to... Lightning strike. I guess we're waiting for a lightning strike. Come on. Oh! So do they not catch? Like, until there's a certain density, I guess? Like, these are dying out on their own. Interesting. Sand piles? Ooh. It looks pretty. This is density, I guess? More than 4 grains is unstable. Whoa. This is cool. Like, this is straight up art. Like, this is where math and art intersect right here. Do you toggle drop at center to drop anywhere? Yeah, I was just looking at that. Oh my, dude, that's so cool. I think this is like this is straight up just like a variation of Conway's Game of Life. Instead of 0 or 1, you have like 0, 1, 2, or 3. I guess it's eventually going to get filled up once everything gets to 3 grains. Or is it... Are they sliding off the edges or something? Ooh. It's making cascades now. Once you get enough of them, like, built up. Oh, that's cool. To Alex problems with the forest fires? That makes sense. I can see that. Oh, wow. I love this. Icing model of demagnetization after heating a metal. Hmm. Okay, I need to go back to setting after this one, but I do really love a good visualization like this. Ooh. I don't know what icing is. I've heard that term before. I don't remember what it means though. Yeah, Fizzbuzz. I do know that the Veritasium has a website, but there's some cool stuff here. I thought I wanted ferromagnetism and statistical mechanics. Okay, that's why I don't know it. Dynamic dipole moments of atomic spins. Hmm. Interesting. Using conformal field theory. Yeah, K-Parts. Thank you for linking it. We couldn't what? I've given you my ID, Google. Like, what more do you need? Actually, I don't know if I did on this account actually, but YouTube makes you give them your ID if you want to like live stream on YouTube. But me, I might not have done that when I made the non-factorial account. Actually, no, I didn't make a different account though. Did I? Oh, I kind of did. I don't remember. This is what you would. This is what it would look like if you did an infinity by infinity grid of the icing model at the critical temperature. Ooh, this does look awesome. YouTube compression aside. Supercriticality, exponential power laws, similarity at all scales. Hmm. Neuron firing path lengths? Really? That's awesome. Oh man, it's been 2 hours. So I was going to do this example. So you can just freely put a principal value in front of this integral because there's nothing wrong with it in the first place. So the principal value is always going to equal the original thing. And then we're going to do the thing that would be sketchy if not for the principal value, which is converting the sign to an exponential. And that's potentially sketchy because we no longer get the cancellation of the singularity at 0. But the principal value makes it okay. And then from there you can proceed. Sudoku that took you 2 hours? Oh my god. That sounds like a nightmare, I'm gonna be honest. Okay, and then the scary thing, multi-valued integrals. Integrals with branch cuts. Our science teacher made us do a Sudoku in binary? Is that not just a 2x2 if you only have 0 or 1? Oh wait, no. Okay, never mind. You probably are still doing full numbers. I was thinking like it in regular Sudoku you have the digits 0 through 9, so you have the 9x9 grid. Or yeah, or 1 through 9, I guess. If you only have 0 through 1 in binary, don't you just have a 2x2 grid? But I assume you're still doing 9x9 and you're just writing out the full binary. 0 to 15, ooh. Alti Towers? That sounds familiar. Is that the name of a show or something? What the hell is this, Fembox? These aren't hints. Also, this is in DE. In Dutch? No, German. Deutsch. I don't know how you interpret these clues, and I don't know how to read German either, so... Okay, so... You know what, maybe we're gonna save the multivalued integrals for later. I want to write down the formulas for Fourier and Laplace transforms. You have to build the grid as you go? I don't know what that would mean. Where's Fourier? Oh, here we go. I found Fourier. And the inverse. Oh, wait. I remember being bullied a few weeks ago. Because I was writing my integrals with the dt first, and I just found out where I got that from. Like, instead of putting the dt or dx at the end, I was putting them first, because it just felt natural to me in the moment. And I got bullied on stream, so I changed it back, but I just realized, in class, we actually did use that when we talked about Fourier's theorem. Right there. That that's an integral d lambda integral d tau. Okay. You guys made fun of me. Unbelievable. Oh, I just lost my page. It's okay. Or I'll see the page I was trying to save. Minus infinity. Ah, that's terrible. Minus I lambda t. Oop. Of lambda d lambda. Since I see a full population populating the virtual world. Is still going, creating children. Nice. Yeah, these shapes are really cool. It's been like bothering me a lot. Like, how do you make math more approachable for people who don't like math? And I wonder if that's a strategy to bridge that gap. Like talking about the intersection of math and art, and do things like Conway's Game of Life or something like that. But in a video game, people have tried. It's not easy though. I did hear in what's that game? I think it was Alan Wake too. You have to straight up solve a system of equations in one part. Visual models are helpful for me. Yeah, like I think visual things are definitely the key, but it's still like how. Yeah, and that's true. Some things just don't visualize either. Yeah, it is. I keep calling you Famish out of habit. I should start calling you Famistral because that's what you changed your name to. Um, Fami is fine. Okay. Made a video about something similar. Oh, nice. Yeah, I won't watch it now, but I'll keep this up. Because I've seen you in other videos mention like how to talk about math people who don't like math. I didn't realize you had like a separate video on it. I want to write down the Fourier transform. What? Oh, I was. Oh my god, I'm sorry. I hope that wasn't too loud on my mic. Sorry about that. Fourier transform for a derivative. think it is tough. It's probably best to just not force math. Talk about things if there's math connection pointed out. Most people are math charmed. I know it. I understand why it happens, but it really bothers me when people just shut down with math because it feels like a judgment on me when I try to talk to someone about math and they just shut down. Like I never try to force it on people, but if they like bring it up or organically happens, I'll talk about it. But like I don't know. There's one time when I was playing Daisy and I was like talking about the game, and I just briefly said like, "Oh yeah," and I also like math, and then I went back to talking about the game, and then they literally said, "You said the word math, I'm leaving," and I thought they were joking, but they actually left. It's like, God damn, like what can I do? You somehow got into math? Yeah, were you like, how recently was that for you? You like puzzles? Okay, yeah, that's like a common way to get into it. Okay, I think that's everything I want to write down about Fourier. Let's write down things about Laplace. I want to do an example with Fourier, but I want to write down formulas first and examples. Hey, Sakno, sad news? Oh. What is it? Oh, causality. I need to know about causality. Ugh. Oh, I'm so sorry to hear that, Sakno. I'm sure you gave Coco the best life you could. That's always so tough when a pet dies. How old? What was Coco? Puzzles are the best. I like some puzzles. Other times I just feel like I don't really like the feeling of being quizzed by someone and puzzles sometimes make me feel that way. 15 died of kidney failure. His phosphorus levels were barometer breaking. Aw. 15 is a good long life for a dog, though, at least. That's terrible, though. Do you have any other pets too, or was it just Coco? And if you'd rather not talk about it, please uh, feel free to just not respond. But just Coco, yeah, that's even worse because it feels like emptier. When you were 12 years old, oh, that's a long time. cats that I had growing up both died while I was away at college in another state, and I always felt bad that I wasn't there. But that's just the way that like life went. Yeah, the cats I had them. I forget how old I was, but probably around 10. We adopted older cats, so it would have died around the time I was like 19 or 20, I think. Not wanting another dog because I feel that would replace him. Highly affectionate dog. Not about play, but about love. Aw. Coco sounds like a very good dog. And yeah, I think either way you feel about that is perfectly natural. Like, I would completely understand like not wanting to get another dog, and I would understand if you did want to, because they have such an important place in your life that I wouldn't blame someone for wanting to try and fill that place again. But you know, you you also love Coco, and Coco was unique, so there's no other pet that can quite fill that same gap. Just want to be petted and cuddled. Aw. It sounds like he had lots of cuddles though. Like he was probably pretty content with his life. Can't fit this in. I think I forgot to write about Fourier transforms. Saying goodbye is one of the hardest things we have to do. Yeah. Yeah. It's time heals all wounds. Leave scars, but it'll heal. Or I wonder if by causality. Hmm. The professor this class made a big point about Laplace transforms and the causality condition, and I didn't really understand it, I would say. And he said it that causality would be a thing on the exam. Hmm. You know what? Let's actually look in the notes for causality. In these notes. Well, that's not good. So the word causality is nowhere in this PDF. These figures are a little rough. Hey, Dumwood. And yes, Sock, now that makes sense. Oh, we need to talk about convolution. That's even just a homework assignment. Nothing much to do, Mud. How about you? Ooh, delta function. Nice. I think we could have a delta function get thrown at us. I do. I've only eaten pierogi one more time. I'm planning to eat some more tonight. They're frozen, so it's no rush. And I've been too tired to cook most days recently, so oh. In the formula we had in class, it was minus ik to the n. This is plus ik to the n. I'm done with A-level maths and for the maths. What would be the next realistic step if I want to get into math even more? You know, so the tip of the iceberg, you want to start learning stuff beyond A-levels. So if you've done A-level further math, I think it means that you know calculus. And that's great because that's like the stepping off point into all sorts of, like, that's kind of like where math starts to branch off into many different things. And it's kind of up to you which path that you take. So like genres of math I would say would be good to look into would be if you I'll start with naming some like applied things. Differential equations. Really that's like I feel like that's like 90% of applied math is differential equations. And you can like yeah, so like if I were you, I would just oh you probably don't know multivariable calculus, and that could go either way. I would call it applied because I like applied math, but you already learned stuff in differential equations. I bet you've learned the basic differential equations. I would bet you don't know about Fourier transforms, Laplace transforms, or partial differential equations. Like differential equations are really deep. Polar, that's a stepping off point. Multivariable calculus is like three-dimensional calculus. So double integrals, triple integrals. Integrals, gradient, divergence, curl. Think if I had homemade. Oh, hey, Anakin Luke. Yeah, that when I first did my face reveal, when I start a few months after I started streaming, people said I look like Ed Sheeran. So that's a story behind that. Think that in any homemade pierogi they would be too tempting. They are pretty tempting. Fourier transforms and convolutions. Yeah, Zach. I just realized there's a conflict between one of the formulas in my notes versus in that book I was looking at. But I want to write something down about convolutions in my cheat sheet. So I'm not even done yet. That's like stuff I kind of put in applied math, even like some physics. Here you have analysis, which is the theory of calculus. This is all like the proofs and things behind calculus. You would start with real analysis, then you would move to complex. You can move to other things too. Biology, true. Mathematical biology is a thing. Shout out to physics. The physics was last seen playing Dragon Ball Sparking Zero. No, I don't care if it Fizzbuzz. There's an analysis. There is, I was about to say algebra. I'm going to say abstract algebra. Group theory, ring theory, field theory, etc. There is linear algebra. Matrices, vectors, linear transformations, which you may have gotten a piece of this. Linear algebra is pretty deep though. Number theory, which is hard to describe. It gets really advanced. I would say you could start studying it now though. You do not need very much prerequisites to start studying it. Discrete math, like discrete math would be discrete math and number theory would be good prerequisites, like set theory, logic, combinatorics. Oh, statistics, which could also be, that might be, you could study statistics in a pure or applied sense. Same with analysis. So these could kind of go either way. The theory of numbers, yeah. Yeah, trust me, matrices go a lot deeper than you've probably learned. Yeah, so like this is just like a smattering of things that come to mind immediately. Oh, good. Yeah, eigenvectors and eigenvalues are really good to know about. Things so like it'd be cool if you learned about singular value decomposition is a really cool thing. Spectral theorem is also a really big idea. It's like, oh yeah, so linear algebra would be a good thing to know. Statistics. I'll get to that in a second. Famistral. Principal component analysis, true. Yep. And so if you, so obviously I just put up a whole bunch of things that, like you could spend a lifetime studying at any one of these things. I think a really good place to try and get an idea. Oh yeah, true. There's numerical methods. If you just want to get like a general knowledge of what different parts of math deal with, I would really recommend just start getting random videos off 3 Blue 1 Brown's channel. To lesser extent, Veritasium is also really good for this. But he makes like the 3 Blue 1 Brown makes really good introductions to like everything in math. So I think like Math YouTube is a really good resource for this. You just figure out like what type of things like get you interested, and then from there the next would be like finding a good textbook to start learning about it for real. Yeah, no worries. And if you ever like if you think you might be interested in a certain like topic, like please do like come back and ask for like more guidance on what to like how to pursue it, because I'd love to help like support you there. Okay. So Famistral asked, how do I get started learning applied complex analysis, or is it too advanced for me? You could start learning, I would say complex analysis is probably a little bit too far beyond where you're at right now, Famistral, because when the word analysis comes into play, that would be like calculus, and I don't think you've built up to calculus quite yet, but you are like on your way there. You could start learning about kind of you could think of it as like the baby complex analysis, which is complex variables. So you're learning about complex numbers without the calculus. And there's some interesting stuff there. I think the really cool stuff comes about when you start including calculus, but if you wanted to, you could start learning about complex variables / complex numbers. I think I assume they're not really going to shine for how useful they are until you start learning calculus too. But like if you tried searching for complex variables, you'd find a lot of resources focusing on that. Just find a book called All the Math You Missed But Need to Know for Grad School. This has an interesting overview of many areas of math. Really, by Garrity. To know for grad school. Garrity. Okay, like the second thing that popped up is an actual PDF of the book. I was just looking for like a store page, but What does this talk about? Oh, nice. So yeah, like learn Python this summer. Oh yeah, that's good to know. Yes, even a bit like this Doomwood might be a good resource for you just to get an idea of what math is like. A lot of stuff will probably be a little bit. It might assume more knowledge than you have right now, but you can start seeing what things look like and what kind of problems they might deal with. Your advisor recommended it to you. Nice. And it looks like KPARS is suggesting some cool channels in applied neuroscience, which I'll have to check those out too. Hardlocked, you wrote a phone app this week. Use a few linear regression models for future predictions. Ooh, okay. Nice. That's stats right there. Oh yeah, I forgot about measure theory. I guess that you could consider that analysis though. Yeah. Let me see sock now. Oh, what a good dog. So cute. I'm sure Coco was very well loved. First one does math, visualization, videos basically. The middle two are stats. Last is neuroscience. Okay. Um, data science. Would data science be a good career? Some people told me it's a trash career. In my opinion, just study the thing that you like. If you study something for a good job, it if you don't happen to like that thing, it's going to be a really difficult time. And the people are giving you advice based on the job market now. The job market when you graduate might be entirely different. There's a bunch of people who have been studying programming, being told they can get a good job as software development when they're probably going to be replaced by AI, or at least I imagine there's going to be a lot fewer. There's going to be a lot less need for software developers now that a single experienced software developer can get a lot more done now with the help of AI. So what might have been good advice before is now bad advice. Might be, yeah. I mean, almost definitely will be. So that's why just study the thing you like. Trying to make predictions about what the job market will be like when you graduate is pretty futile. Mark just bought me AI for coding, so much more productive. You now have AI write 98% of your code. Yeah, I mean, it probably does a pretty good job of it too. For a group project that I've been working on, I wrote the first iteration of code to try and simulate networks in biology. It was taking way too long to run though, like more than like after 8 hours wasn't even halfway done. And another group member uh, optimized the code and like made it run so quick, like within like 10 minutes. And I asked him how he did it. At least for certain things, it was just Gemini. Like, I think some things he wrote himself, but like a good amount of it was just AI, like fixing it and making it way better. You don't want to get into SWBS since it's so miserable and depressing. Yeah, so I was using just software engineering as an example of people who were told they should get into that thing and then found out that they're not really getting what was promised. That's kind of interesting. Are these both correct? Like, this is minus I lambda for the Fourier transform of derivative. And this is positive I lambda or k. Leak code, yeah. It's like a classic thing. Slack, now I see your second picture. That's so nice, just cuddling with your pet. That looks right. The Fourier transform is a dual. Was the reverse FT or the normal FT? I don't know. Why is this minus I lambda? Oh, we have different definitions. That's annoying. Okay, yeah, the issue is that's a minus for the forward transform. And in our class, we do minus for the inverse. I know you can also mess with the 1 over 2 pi. Like, you can put it with either one or even do a mixture. I didn't realize that you can mess with it makes sense if you can mess with the minus sign. Like, the thing that I don't quite get with the Fourier transform is, like, they say that the inverse Fourier transform is just another Fourier transform, but it's not the exact same one. Like, one has a minus sign, one doesn't, and your coefficients are sometimes different unless you make them symmetric. So, I don't know, but e to the soy pi omega x can also be a kernel. Right. Yeah, in my scientific computing class, we just learned about, like, Chebyshev polynomials, which is like another type of kernel that you could use. But that discussion kind of, like, it was really short. Like, we didn't really learn what any of that meant. Now I don't want to use the formulas from this book then. I wanted to just borrow the convolution formula. I could derive it. Did we do? Oh yeah, did they? I don't think they did convolutions in this book. This book should have the same definition as in class because the professor wrote it. Ooh, there's a formula that I want to write down before I forget. When you have to take the inverse Fourier transform of a Gaussian, the convolution definition should be the same? Okay. It's not that hard to derive it, too. But, that's good to know that I can just use the other one. Aha! Okay, this... I don't know if it might not end up being all that important, but, if it does end up being important, this formula will be really handy. the integral from minus infinity to infinity of e to the minus k squared x squared plus I omega x dx is equal to root pi over k e to the minus omega squared over 4k squared. Because this is really annoying to integrate, and you sometimes have to do this when doing inverse Fourier transforms and stuff. So it would save a lot of time to just use this form that we were given in one of our lectures. We'll shift that down because we don't know where we want to put it yet. Okay, convolution. Yeah, I remember this book's explanation of convolution is kind of weird. Does convolution, do we do it in this other book? Here we go. Parseval's? Oh, yeah. What does Parseval formula say again? Oh, it's a different one? Oh, down here is the actual. Huh. You sing in summation form? Interesting. Oh, probably because, yeah, you'd more often have this type of stuff in discrete situations. Phobos, hello, hello. How's it going? You good? That's good to hear. Hustling. Noish. Painting extraordinaire. I think we'll write down this formula right here. Actually, we can even just do, instead of writing this integral on the left side, we'll just do inverse Fourier transform. I'm running out of room to write example problems. I thought I would be able to fit all my formulas onto just the front. Wait. Convolution goes from minus infinity to infinity? Right? Do I just not remember this? Oh, I guess it does. Okay. God, Kasai! I'm not using Kasai. I refuse. Gonna do X prime. The other day I got you and Globus the Elder mixed up in my head. I was thinking Phobos? You know, personality-wise, that they're not too far off. I know they both like board games. There's a World of Tanks streamer who with their accent would call me Phobos. That's funny. They're in Ukraine. Oh dang. I hope they're well too. Um. Okay, I think that's hopefully everything I want to write down about Fourier transforms. And then we can go back to doing Laplace. How much? I mean, I don't know if it's going to translate to a physical note credit. I might already be over budget for all I know. But this is still a good exercise in just figuring out what's important to write down. If I end up having to cut something. So for Laplace transforms, I want to write down what to do with derivatives. Because it's not that hard to get the formulas, but integration by parts is annoying. And there's also certain assumptions that you make when applying these formulas, right? So that we've been making in this class, and I want to track what those are. So the Laplace transform of a first derivative is equal to S Laplace transform minus f of 0 and this assumes that e to the minus st f of t goes to 0 as t goes to infinity. And in this class, we've just been getting the solution and checking it at the end. When we make this assumption, the Laplace transform for a second derivative is s squared Laplace transform minus s f of 0 minus f prime 0. And we assume e to the minus st f of t and e to the minus st f prime t both go to 0 as t goes to infinity. Okay. I guess for inverse Laplace transforms... Oh man, causality. I'm going to interpret causality as meaning with the Bromwich contour, causality is when you close on the right, you get 0. Oop, I keep bumping my mic. I'm so sorry about that. Is a Bromwich contour for t greater than 0? Is a Bromwich contour for t less than 0? And I'm going to call that one causality. Because we should always get 0 for that piece. Okay. So for the example problems, I want to write down a particular integral involving branch cuts, because those are some of the hardest integrals we're going to be tested on. And he kept repeating one specific example that we did a while ago in lecture. Trying to find it. Where is it? Aha. Okay. That's not much room. So the integral that we were doing as an example is from -1 to 1, 1 minus x over 1 plus x to the 1/3 dx. And you use complex numbers for this, but there's some subtleties. Oh god, this example is so long. But this is really important because I don't really understand this integral, so I want to know how to do it. So we're going to consider the complex function f of z equals z minus 1 over z plus 1 to the 1/3. And we did a switcheroo here. This is z minus 1, but that was 1 minus x. And he says doing that switcheroo is easier. We'll have to fix it later, but it's apparently easier if we do it. And then we'll make local polar coordinates. R1 e to the I theta 1, R2 e to the I theta 2, and f of z becomes R1 over R2 to the 1/3 e to the I theta 1 minus theta 2 over 3. Theta here is restricted from 0 to 2 pi. And from here, you need to do an A/B test to figure out the branch cuts. It was kind of fun though. He said to save time on the final, just guess where the branch cut is, solve the problem, and then come back and justify where the branch cut is at the end if you have time. It's better to get the right answer with incomplete work, I guess. I'm gonna write A/B tests. I think I know how to do them, but I need to be reminded to do them. The moral of the story is this has a branch cut from -1 to 1 though, with the thing restriction that we've chosen. And then we're going to use a dumbbell contour. There's our branch cut. There's our contour. It's oriented like that. We're going to say C1, C2, C3, C4. So then on C1, x minus 1 equals z minus 1. So r1 e to the I theta 1. Theta 1 is equal to pi. Yes. I said technically approaching pi, so I'm going to do an arrow. And r1 is 1 minus x. Oh, so is the theta equals pi that... Oh, okay, so that's where the switcheroo happens, I guess. And then x plus 1 is equal to z plus 1 equals r2 e to the I theta 2. Theta 2 is approaching 2 pi, so r2 is 1 plus x. Which means that the integral on C1 f of z dz minus 1 to 1 r1 over r2 to the 1/3 e to the I theta 1 minus theta 2 over 3 dx, sure. Oh, okay, and then we're plugging things in that we just found. So the 1 minus x just kind of pops out naturally. That's convenient. And so the point is this is the original integral times a constant, so we can deal with that at the end. I'm not going to repeat all the steps. The integral on C3 is going to follow a similar process. Oh my god, dude. I'm not going to be able to fit in a PDE. I still think I'd rather have this problem than a PDE for an example on my note sheet, but I wanted to have both. Okay, then that's a constant times the original integral, so we're in business. The integral in C2. Well, let's start with just talking about C2 in general, because it's a circle, it's a little bit different. R1 goes to 0. The denominator is constant, throw it out. C2. C2 is this circle right here. And so the distance as measured... Throwing out the denominator is throwing out the distance being measured from this point over here. And so as the radius of this circle goes to 0... Yeah, I guess it makes sense that the distance this point is measuring is going to be constant at every point on the circle, because the circle is becoming infinitely small. I guess. And we just simply say the integral on C2 goes to 0 as R1 to the 1/3 times R1, and the extra factor of R1 comes from dz equals dr1 e to the I theta. And then a similar process on the other circle for C4 gives you that it goes to 0. But you get R2 to the minus 1/3, which then gets saved by the dz. So it really matters for this one. So the conclusion, which I guess I'll fit on the left side here, the integral around f of z dz is equal to e to the minus I pi over 3 minus e to the I pi over 3 times I. Oh my god, we're not done yet. I don't have enough room for this problem. I thought that was the end. I forgot that's not the end. I don't have room to write anything more. But from here, we need to use the residue theorem, but we're enclosing a branch cut is the issue. For reasons that I don't understand, you could have... Well, I know why you can do this first part. You can expand the dumbbell contour just into a giant circle with radius going to infinity. I don't know why that fixes the problem of enclosing a branch cut, though. But the point is, if you do that, you use binomial expansion on this. Plug in polar coordinates. God, that's so complicated, though. I think the more rigorous way of doing it is to... reverse the contour, because that means you're now, instead of enclosing the inside, you're now enclosing the outside. So like including, you kind of like are flipping your domain. So that actually gets rid of the branch cut from the area that you're integrating. But the issue is that you have to deal with any singularities that are outside the contour. We don't have any here, except for the point at infinity. So you make the substitution 1 over t, stick a negative sign in front. And you need to get the residue at infinity. Ugh. Either way, that's kind of a pain. Jasu, holy crap. It's been a batshit crazy few months. I was wondering where you've been. I hope that you've been well. Have you finally moved yet? Like I feel like the last I heard from you, you still hadn't moved. I've had a crazy, at least like, not necessarily months, but at least like few weeks here with the amount of homework. I was making a cheat sheet for that we're allowed to take in a little like card with notes on it into our final test for my complex analysis class. So I've been figuring out what I want to put on that. I want to write this down physically on a piece of paper later off stream. I might have just finished it though, more for lack of room. Still in the UK. Wow, went to Finland last week for a postdoc interview. Okay. So are you gonna do a postdoc and the bachelor's still, or what's the deal with that? You're gonna do, wow, that sounds like a lot of work. Good luck. Get some water. You got offered the postdoc? Oh, congrats. I'm not very familiar with how postdocs actually work. Like, do you know what you're going to be working on specifically for a project? Clonk, over on the YouTube side, hello, hello. I hope your day is going well. Okay, I've been debating if I want to plow through it. I haven't streamed for 3 hours already. I kind of want to do the sample final exam that we were given. I thought it would take me, I thought I'd be able to make this cheat sheet quicker. I couldn't, but I kind of still want to do the sample final. You have a rough idea of what you're working on, but also applying for some grants. Okay. Yeah, because like I've heard the term postdoc, and I know it's something that you do. It's some kind of extra research project that you do after a PhD. That's kind of all I know about them, though. Okay, so the issue with the sample final we were given is that we're given the solution key only, so I've got to try to not look at the solution. Working as a researcher? Okay, fair enough. This game's not too bad where the one meets. Oh, nice, nice. Peach tea. Talked to one of my professors to get into topology next semester. Fun stuff. Ooh, good luck. Okay, maybe I should do a pinned comment here. So this is about to be me studying for, like, taking a sample test, to study. So this will be the rare time on the stream where I ask that people specifically do not help me with the math that's happening. The answer is C. Dang it, Peach Tea! If we give fake answers, you know, that might be good training. Oh yeah, Clonk. That's very kind of you. Okay, so I guess you won't be able to see it. I'm going to bring up the exam and try not to look at the answers, because unfortunately we were given just a solution, so we weren't given like a clean test. Okay, so wait, I should read the introduction. So sample final. We're given an hour and 50 minutes. He said it was designed to be done in an hour, though. Closed book, closed notes, besides our note card. No computer apps such as Mathematica, Wolfram Alpha, or Maple. No phones, no computers. He never said no calculators, interestingly. But I don't think we're allowed them either. Okay. Lobster. Buzz Lightyear taught Lobster that there's stuff beyond infinity. Buzz Lightyear taught me that too. Your Cantor also did. Did you know if the sun rises, then the answer is the answer? That's a true statement, Jasu. I should just write that here. I guess that'll be true for the next couple hundred million years, right? Use residue calculus to evaluate that integral. Ooh. What are you? So wait, actually, I should have split the screenshot up. I want to see just part A for now. We'll deal with part B later. Actually, I want to get a screenshot of part B right now. Don't look at answer, don't look at answer, don't look at answer, don't look at answer. Okay. I should set a timer. Okay, stopwatch is going. Use residue calculus to evaluate this. Okay, so I did write this down on the cheat sheet. You know, I'm allowed to use the cheat sheet. It is this bad boy that I want right here. So cosine, we're basically taking z equal to e to the I theta. Why did the music stop? I'm gonna play the song. dz is equal to just I. E to the I theta d theta. Hour and 50 minutes. He said he makes it so you only need an hour to complete the exam in theory. But we get an hour and 50 minutes. We did do pizza slice contours. Yeah, Milk. Hope you're doing well. We did box contours too. Did dumbbell contours. We're not gonna get any pizza slices on this test though. The professor did say that. Kind of assume that these are the formulas that were given. Yeah, we did. So cosine from this formula, cosine of theta is equal to z plus 1 over z over 2, and sine z minus 1 over z over 2i. So that means I is also equal to the contour around the unit circle of E. Ooh. This is a little disgusting already. Ooh, wait, what the hell? It is the song. Yeah, Mousak actually asked me if he could ask me some questions, and I had to tell him no, unfortunately. I felt bad, but... What the hell? This is a crazy integral. He said we wouldn't get any branch cuts. So what I want to do here is it is crazy clunk. I want to sub out that theta, but it's going to be in terms of ln is the issue. So maybe this is actually the wrong move. I think we're actually going to say that, yeah, we're going to use this first on this cosine. I is equal to the real part of j, which we're going to call the real part of 0 to 2 pi e to the cosine theta. E to the, I theta minus sine theta. Oh, aha. This is the trick, because now it's leading into the second formula. Okay. So then J, just getting rid of the real part for ease of writing for now. We're forgetting about the Z sub entirely for the time being. We might need it later. So these exponents are going to add. So we're going to have a cosine theta minus I sine theta, which incidentally is e to the minus I theta. So we're going to have e to the I theta. Well, plus e to the minus I theta? Not a fan of that. Maybe this is okay though. Maybe we need to use a power series now. Just continuing, like, this formula led it into this formula, and I guess maybe it can lead into this formula now? So here, Z is going to equal to I theta plus E to the minus I theta. Um, I theta e to the minus I theta plus I theta plus e to the minus I theta squared for 2 factorial plus dot 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 d theta. Okay, what do we do with u? I still don't want to use this sub up here. Hmm. This is potentially, well, no, not to say Jordan's lemma. Okay. Different strategy. Slightly different, at least. Keep this e to the I theta separate. And then we'll just Taylor expand the e to the I minus I theta. Is this better? Yeah. This is a lot better, isn't it? E to the I theta plus 1 plus e to the minus I theta over 2 factorial. I think they're going to zero out except for the constant term. Yeah, and so I think that's the key milk. And just 99% of the time on the stream, like, feel free to help, but this one time, this is like a sample final exam that I'm trying to study from. And so, like, this is like the one time on stream where I ask people, like, not to help me out. At least until after. So I guess just be careful about, like, saying too much. Yeah, I'm trying to, like, test my knowledge here and see how much I know. But, like, at any other time, I don't mind it at all. So I think I'm going to argue this is 0. This is 0. Yeah, and I think everything else is 0 except for this, which is just 2 pi. That's what j equals. And I equals the real part of j, which equals 2 pi. That's kind of crazy if that's true. Uh, that thing just comes out to be 2 pi. I didn't use residue calculus though. Uh, I never used residue calculus. What if I don't need to use? Did I do something wrong? Mathematica user spotted. Okay, well, I guess let's investigate what happens if we shoehorn in some residue calculus. From this stage, if we apply the sub from up here, maybe that's what they wanted us. To do. Around the unit circle, z plus 1 plus 1 over 2 factorial z, 1 over 3 factorial z squared, plus dot dot dot, dz over iz. Yes. So when we multiply that in, we're going to get the 1 over I can be way out front. 1 plus 1 over z plus 1 over 2 factorial z squared. Oh, this is turning into just e to the minus z, right? Or e to the 1 over z, rather. dz. Okay, and so we're going to get 2 pi again. So, okay. Yes, it's a very important fact in complex analysis that if you integrate around the unit circle, this bad boy is 0, this bad boy is 0, this bad boy is 0. Everything is 0 except for that thing, which is 2 pi I. We could get the residue here. We could like show that work. The residue is just 1. I'm not showing that work. So we get 1 over I times 2 pi I times the residue of 1, which is just 2 pi. Okay. Feel pretty confident in that answer. We don't need residues though. Part B. Evaluate using simple contour integration. Yeah. Oh, sorry, using complex. I changed the complex into simple. Oh, that's easy. Oh yeah, clock. Oh wait, how did you get the dragon skimmy? I just noticed it. I've been seeing that around. You can't tell. I get it. I mean, how you can't tell how to do this problem? That's completely understandable. Okay, this is probably going to be Jordan's lemma. Ooh, there's a subtlety here. There is no singularity at 0 initially, but there will be if we try to make that an e. If we try to convert sine to an e to the ix, we're going to create one. Oh, you have to sub to someone streaming OSRS? Okay. Dang. That's good to know, though. Hey, Obi. We're doing well. So we're going to slam a principal value in front of the integral. And then I'm going to say principal value of the imaginary part of something that I'm calling j, which is equal to principal value of the imaginary part. The big reveal is that j is e to the ix over x squared plus 1 dx. And we can do a swap skidoo on the imaginary and the principal value. Squared plus 1 dx. Geometry Dash might be harder than every class I'm taking right now. I never played Geometry Dash. Okay, so we're gonna use Jordan's lemma. If we're gonna use Jordan's lemma, we do need to verify. Well, okay, let's do this one step at a time. We're gonna consider e to the iz over z principal value z squared plus 1 dz, where c, we have singularities at 0 and plus and minus I. Our contour will be a circle in the upper half plane with a gap right here. Studying because they're shapes? Yeah, exactly. That's math. So we need to check that the conditions for Jordan's lemma are met. So we need to take the limit as z goes to infinity of like that function. We can bound it above by the absolute value. Like, I feel like this should be obvious, but we have to actually prove it. Which is unlucky. This type of thing that we would skip, like Professor said that we should just skip doing this and come back to it. At the end if we have time. But I'm just gonna do it. And this is smaller than. Do we want smaller? Because we're about to flip this. No, this is the bad direction. So we're going to do this, and technically we do need that absolute value out there. It's not really that important though, because the magnitude of z is going to infinity anyway. Okay, so if we flip each side of this inequality, we can now say, hey, crouching jab. Yeah, it is. They're just making us like really justify it, which is annoying. That's how we were doing it in class. And so this next part, I forget how they justified it, but I'm just gonna go ahead and chop off the minus z. And that goes to 0. Okay, so this is the proof that we can apply Jordan's lemma. It's going to abbreviate as JL. By Jordan's lemma, the integral on this contour is equal to the integral on just the real axis. The principal value. But by residue theorem, this bad boy, generalized residue theorem, well, okay. Generalized residue theorem. Okay, 2 pi I times the sum of the residues that are enclosed. This is the only residue that's enclosed, which is at z equals I. It's a simple pole. So I should maybe write down the formula for higher order poles. I'm like, not now, but on my cheat sheet. Because that's always annoying to remember. And it's possible he would throw one at us. For simple poles, it's a lot easier though, because you can just take the derivative of the denominator. So which will be 3z squared plus 1 if I would at z equals I. So we get e to the minus 1 over minus 2. Minus 1 over 2e. Plus pi I times the sum of the residues you're approaching. 0 is a simple pole. So same formula. Which is 1 over 1, which is 1. Okay. So we end up with pi I, the 2's cancel, 1 minus 1 over e? That looks familiar. Okay. Well, we have the answer now. I is equal to the imaginary part, the principal value of j, pj's. And we just found that that is the principal value of j is pi I 1 minus 1 over e. That's a terrible j, by the way. Pi 1 minus 1 over e. That looks like a pretty reasonable answer for this. What? Ooh, do we need conditions for generalized residue theorem? I don't think so. Only poles, yeah. I guess we should probably say that. Simple poles. Okay. I think that's number 1 done. Now I'm going to bring up... I need to not look at the solution. I'm going to scroll down to number 2. Okay. Don't look at the solution. Don't look at the solution. Don't look at the solution. Okay. Ooh. Okay. So, Laplace transform. I got this part unlocked. What's the rest? 0 to infinity e to the minus st. It's all about Fourier transform, Boole Laplace. I kind of agree. Fourier transform is just easier. But I think you have to use Laplace transform sometimes. Or, I don't remember. So we need to integrate this bad boy. Is it? It's not even. Really? Well, that's annoying. We can go to the exponential definition of sinh, I guess. Okay. Oh, well, yeah, okay. Now we can just integrate that. Wait. I did this wrong. Or I made a sign mistake. Should be minus. That one is plus. That's better. Okay. So this will be e to the minus s minus 1 t over negative s minus 1 minus e to the minus s plus 1 t. That'll flip to positive s plus 1 from t equals 0 to t equals infinity. Okay. So t equals infinity. This is where the sign of s starts to matter. So if s is greater than 1, we are guaranteed this is a negative exponent up here. We are guaranteed this is a negative exponent up here. So they'll both go to 0 as t goes to infinity. So then for t equals 0, this will become 1. This will become 1. Okay. I guess that's my answer? Are there any other values of s? I don't think so. This thing just diverges. If s is less than or equal to 1. Wait, equal to 1? No, equal to 1 doesn't make sense with the denominator. Less than 1, we run into issues with this exponent blowing up. And then eventually this exponent blowing up. Okay, I'm satisfied with that. Hey, Chaotic Diamond. L'Hospitals? I don't think L'Hospitals... This is t going to infinity. So L'Hospitals won't help us with these. Obtuse Baboon Babu. Great name. Also good for diffusion problems in plasma physics? That's cool to hear. I wouldn't know. The limit as s goes to 1? I don't think we're doing that anywhere here. I'm not sure what you mean by that. You know, first time chatter, I don't remember that name though. I guess maybe it's just been a minute. You know, if you like plasma physics, there actually is a streamer on Twitch who has a PhD in plasma physics, actual education / Dr. Gold. I don't know much about him myself, but if you don't already know him, you should. Okay, so I think I'm having this 2a. What is 2b? Don't look at the don't look at the answer. Don't look at the answer. Don't look at the answer. Okay. It's so hard to, like, the answers just mix in with the questions. So it's difficult to not look at them. Perform the inverse transform to recover f of t. Oh, this is where it's going to get dicey. The inverse is always harder. 1 over 2 pi I alpha minus I infinity plus I infinity. Is it e to the positive st now? Sure is. Okay, what's happening here? S is a complex number. The real part of S is more than 1. So what's happening here? This restriction on the real part of S is what's messing me up here. Because how do you make the Bromwich contour with this restriction? Do we forget about it? I'm just gonna forget about it and see what happens. Because I guess the thing that I'm concerned about is that when you make the Bromwich contour, I can definitely put the vertical part of it past real part 1, but I'm gonna close it on the left, which is definitely gonna violate that restriction at some point. So that's the thing that I'm questioning. Actually, we can treat these integrals separately. It's probably easier. Okay. We have a pull +1, pull at -1. Both of these integrals can use this contour. I guess we can check causality first. Which is t being negative. Uh, call that CR on the right. E to the ZT, which reminds me of ZD, which sounds delicious right now. This gets us 0 because we're not enclosing any singularities, and this equality is by Jordan's lemma, since the limit as z goes to infinity, 1 over z minus 1 is bounded above. We have 1 over z minus 1 is equal to 0. Oh, ZT? Like, I was writing the letters ZT, but there's the Italian, like, or there's like the pasta shape called ZT, like ZITI. And baked ziti is like a common thing that you make, and it's really good. E to the baked zd, where z plus 1 dz is also equal to 0, also by Jordan's lemma. blah, blah, blah. I don't feel like writing that again. Some snack or something? Oh no, that's a meal. Okay, causality condition met. We've done it. We've done the easy bit, which is that piece of the function. Yeah, it's really good. Okay, for t greater than 0. I guess it's basically lasagna, but with a different pasta shape, to be honest. It's not that different. I just had a thought about the restriction on S. I don't know how to phrase it yet, though. I'm wondering if the sign of T somehow saves it, but if I reverse it somehow, but there's no way I reversed it. Because I'm like 99.9% sure that I have this right. Or at least I have this causality with T less than 0 closing on the right thing correct. By jail, yada yada yada. Which is equal to 2 pi I times the residue at positive 1. ut over 1 evaluated at z equals 1, which is e to the t. Yep. Generalize, I mean, I guess just residue theorem. Okay. This is going to work out, I think. It's going to get the right answer, at least. Maybe for the wrong reason, potentially, but I think I'm getting cinch. Again, Jordan's lemma. Again, residue theorem. The residue at negative 1 is e to the minus t. So, coming back to the work from above, f of t is equal to 1 over 4 pi times this integral. Well, yeah. We're still in the t greater than 0 world. One over 4 pi I times 2 pi I e to the t minus 1 over 4 pi I times 2 pi I e to the minus t. And would you look at that? That, my friends, is sinh of t. So combining the results, we get sinh of t when t is positive and 0 when t is negative. Okay. Next question. I think there's only 3 in total. Okay. Don't look at the answers. Don't look at the answers. Don't look at the answers. 3. Okay, 3 is a single parter. Wait. Didn't we say no? Bilinear? Okay, I realize it's closed notes. I'm just looking at what he said would be on the test though. I'm not. He said there would not be any bilinear transformations on the final. What is this balderdash? This is malarkey even. We'll do it though, because that's just it's just how good we are at everything. Definitely not mediocre. Find the image of the semicircular disk of radius 1 in the upper half z-plane under the bilinear transformation. Okay. I think there's going to be a convenient way of doing this that I don't know. Know that in z-plane, the boundary of the semicircular disk is the semicircle x squared plus y squared equals 1 for y greater than 0, and the line minus 1 is less than x. Ooh, that's a good reminder. I would not have remembered to do that line. Okay. Well, for a semicircular disk of radius 1, z is equal to e to the I theta, where 0 is less than or equal to theta is less than or equal to pi. For the semicircular part. So W 1 plus e to the I theta or 1 minus e to the I theta. What do I do with you? We could say that 1 is equal to e to the 2 pi I. Does that help us? I don't think so. Or e to the 0, maybe. Okay, well, let's work on doing this the stupid way. I think this is the smart way that I wrote. I don't know where to take it though. So if we let w equal u plus iv and z equals x plus I y, what do we want? I guess we want to figure out 1 plus x plus I y, 1 minus x plus I y. We want to figure out what u and v are once we apply these conditions on... Actually, if y is greater than 0, these are strict inequalities. I guess let's simplify this first. This is why this is a stupid way. It's a lot of algebra. Nope. I'm going to multiply out the numerator the old-fashioned way. Sometimes the old ways are the best ways. This is not one of those cases. I be rolling, I be rating, I yelling. Okay. I hope that's a good thing. Gather up the real and imaginary parts. Wait. Minus x plus x. Ooh, minus y squared. You want coffee? Does sound nice. We have two y's. The xy's cancel. So that's it. Okay. You make a small cup, but first you hydrate. It's a good idea. Okay, so then on the unit circle, x squared plus y squared equals 1. Aha. Okay. Or sorry, on the semicircular disk. So this is an x squared plus y squared. What happens here? If I fill this out, we get an x squared plus y squared, which is 1. Oh! We get a minus 2x. We get a plus 1. Oh, no. Never mind. Okay. Minus 2x plus 2, I think. So u is a constant, 0. V is equal to y over 1 minus x, which, again, this being the stupid way, we need to do a lot more algebra to deal with that. If w equals 1 plus z over 1 minus z, we need to invert this transform to get z in terms of w. W minus wz equals 1 plus z. W minus 1 equals z plus wz. Z is equal to... Really? W minus 1 over w plus 1? That feels too simple for an inverse, but okay. That is nifty. But yeah, and so the point of doing this is to get x and y in terms of u and v. So I want to get rid of the x and y's there. But here's the thing. This is why this is the stupid way, because now I have to simplify this. Oh my god. I need to learn the good way. They haven't put out the answer key for the homework where we did a problem like this, so I mean, maybe once I'm done, someone can spot the good way of doing this and tell me. But for now, it's the only way that I can think to do it. So I'm going to do it this way. It's the conjugate of that. All right, more multiplication. U squared plus u minus iuv minus u minus 1 plus iv plus iuv plus iv plus v squared. Ah. U plus 1 squared plus v squared. Oh, what's happening here? U's cancel. IUV's cancel. This is so symmetric. U squared plus v squared minus 1 are the real parts. The imaginary parts, we get 2v, or not 2v. U plus 1 squared plus v squared. Okay. So, y is equal to that. X is equal to that. We can plug it in here. Yay for stupid ways. This is so stupid. Oh my god, this is so much work. Yeah, let's get rid of let's get rid of like this denominator, I guess. I mean, this should theoretically clean up. We have a u squared minus u squared, which cancels. We have a v squared minus v squared, which cancels. We have a 2u, which does not cancel. We have a positive 1 plus 1, which is 2. Wow. Wait, what? So I guess we need to solve this for v. Am I stupid? Is v just 0? So either v equals 0 or 1 is equal to 1 over u plus 1. Flip both sides. Or u equals 0? What in tarnation? I have no... This is just the origin? Like... I have no clue. I need to figure out the good way of doing this, man. Okay, wait. Oh no. The pie lost its hat. I should maybe have tried a little bit harder with this. Like, this seems like something. Is this... I don't know. I feel like I'm doing way too much algebra here, but... The conjugate of this. One plus cosine theta minus 1 squared plus sine squared theta. Okay, multiplying out another trinomial times a trinomial. 1 minus cosine theta, because I just love doing algebra. Can't get enough. Sine theta, cosine theta, plus I sine theta, minus I sine theta, cosine theta, minus sine squared. Cosine theta minus 1 squared plus sine squared theta. Hey, color cone. Hope you're doing well. Okay, cosines go away. Let me do that in a different color. Cancel, cancel. All these I signs... Wait, okay, wait. Those cancel. Okay. So we have a... For the real stuff, we have a 1. We have minus cosine squared minus sine squared. Plus I, imaginary stuff, we have 2 sine thetas. Am I winning? Kinda? I'm doing a sample final for my complex analysis class right now, and I feel like I'm doing pretty dang well on it, to be honest. So I have the pinned message, but like, don't help me yet, because I'm trying to see how I do individually. But this is the last question, and it's about bilinear transformations. I started doing it the stupid way. I got something weird, so I'm trying to do it the smart way now. Um, yeah. So this is gonna zero out again. What is this? It's possible to simplify it, right? So we have cosine squared plus sine squared is going to be 1. We're going to have a 2 cosine theta plus 2. So u equals 0. V is equal to sine theta over cosine theta plus 1. Well, what the hell is that? Well, theta goes from... If theta equals 0, v equals 0. If theta equals pi, v equals 0. If theta equals pi over 2, we get 1. If theta equals pi over 4, did you control the math? Or didn't? The math is controlling me, I think. That's an annoying number. I don't know. Can I simplify this any further? If I multiply it through by cosine, it would look almost like some half angles, but I don't think it'll be a helpful half angle. Or would it? She'll make my own. There you go. I'm sure to mess with this thing. This song right now? It's just talking right now. Pale Light by Skeller? Okay, so I mean, okay, well, this is a bilinear transformation. We know that circles map to circles. So this semicircle should map to a semicircle. Wait, does it though? I don't know. What was I saying when I was plugging in points? If theta equals 0, we get 0. If theta equals pi, we get pi. If theta equals pi over 2, we get 1. Is this some weird, like, is it like a flower petal? Like, that shouldn't be right. Like, it's like maybe it's an ellipse. Maybe that's a better way to describe it. Which is reasonable? Maybe? Or is it an ellipse or is it just a circle? I thought circles map to circles. What about the line? -1 less than x less than 1. I think this form is going to be helpful. I don't know what to think about the circle yet. But at least for the line. Probably do something with that. So y is 0. Times 0. So u is equal to 1 plus x over 1 minus x. That's kind of weird. Oh no, okay, it's symmetric. I was wondering about the sign of this thing. Like, I kind of been flipping the x minus 1 back and forth. It should kind of be the same, though. So what is this mapping, though? So v is always 0. X is always between -1 and 1. So u is a straight line when x equals -1. This becomes -1, -1. Equal to -2. When x equals +1, U is equal to infinity? Oh no. Hey, Kisho Katsu, welcome in. This is I'm working on a sample final for my complex analysis class. So I'm working on this question here. Please don't help me. It's not until I'm done with doing this. Normally, I don't care at all if people help with the math. I actually like it, but for this one particular thing, this is me studying, so I'm trying to see how I do individually. But yeah, this is like I said, a sample final that I'm trying to work through. I've gotten a little bit stuck on this last question here. You're absolutely terrible with math? Oh, okay, no worries. You're still welcome here. Yeah, I normally do like math help. It's just like a busy time in my life, so it's a little harder for me to do math help like right now. But yeah, this is really convoluted. PhD. Thanks for the follow, Keisho. Yeah, feel free to share like what brings you here. If you want. You don't have to. Wait. The limit as x approaches 1 of 1 plus x over 1 minus x. That is infinity. Okay, yeah. One from the left, specifically. Yeah. Okay, I have no clue what the hell I have here. If I just go with it in the z plane, we have a semicircle, radius 1. In the w plane, we have a ray from -2 to infinity, apparently. And we have... I don't know what I said this was, if I said it was even anything. I don't fucking know what the shape is, man. I did, yeah, I'm kind of doubting that, but like circles should map to circles. And so I assume a semicircle would map to a semicircle. But I haven't really gotten a semicircle, I don't think. Yeah. Like it shouldn't be an ellipse. I've clearly done something wrong here, I think. Because the second part of this question is like completely out with what I have. If it is some like I'm not getting anything in the lower plane, which the word in the question implies that I should be. semicircular disk of radius 1 in the upper half z plane. Wait, actually, if u is always 0, aren't I getting another line? Wait, yeah, I think I'm saying I forgot about the u equals 0 part. I don't think it's an ellipse. It is just a line of length 1. That can't be right. Pretending to understand all of this as a coping mechanism. I guess for background, I'm going for a master's in applied math. This is a question from a PhD level complex analysis class that I'm taking. So if you don't understand it, I wouldn't feel bad about it. Man, how long has it been? An hour and a half? If this was the actual final, I'd have 25 more minutes. Well, sorry, an hour. It's been an hour and 25 minutes. I feel like I've tried it 2 different ways, and I've gotten 2 answers that don't make sense. For the same reason. I didn't make some basic mistake like copying something down wrong, did I? I don't think I did. The other approach that I could think of trying is to break this down into like component transformations. That's why I wrote this thing right here. So you could think of this as an inversion. Like this part is an inversion. The minus sign is a reflection. The 1 is a shift. Like that's the other option. Oh. That may... Okay. That explains... Okay, so... I think it actually makes perfect sense that this line, it should become infinite. This transformation has a singularity at z equals 1. Okay, so I'm kind of glad I started thinking about that. I was about to just give up and call it a loss on this question, but I think I've done the line part potentially correctly. Also, hi Stuki. What would the circle part do? So first off, inverting a circle and inverting a unit circle, even a semicircle. Ooh. Ooh. I will say it does nothing. It does get flipped to the lower half plane. Okay. New strategy unlocked. We're just gonna do this intuitively. No math allowed. Okay. We're starting with this. After an inversion, we get this. same radius. Then we do a shift. Wait, do we need to do the shift first? We do need to do the shift first. Bruh. Okay, if we apply this, z minus 1. We're taking all the values of z and subtracting 1. So that? And then if we invert that, we're going to get something infinite. Bruh. Oh. I made an oopsie here. When I plugged theta equals pi into that, I said it, the answer, it's actually 0 over 0, isn't it? Guess we can L'Hopital's that. Infinity. Huh. I am still confused. Wait. Oh no. Oh no. No, 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 I'm good, I'm good, I'm good, I'm good. I made a mistake with this, but I did it right. I was about to be like the Punisher. No, 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 no. No, 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 no. I don't know, dude. This is so weird. Because if I do the next step for what I was going to do with pictures here, I would need to invert this. So that's reflecting across the line y equals x. Oh, well, actually, Oh, well, I guess that's fine. Um, the origin would get mapped to the origin. This point would get mapped down here. This point, I guess, would go over to the quadrant there. So we would get... And are we getting that? I think? No. Yes? Can you repeat that question? Yes, I think it's like that. You're not the boss of me now. Okay, so then we would need to multiply it by 2. Which means we have a bigger semicircle. And then we would need to add 1 to it. Which means a shift to the right by 1. And then we need to stick a negative in front. Which... Wait. No, I feel like I did the inversion wrong. I don't think this step is right. I don't know, man. The semicircle it needs to go to infinity and beyond. Because this has a singularity at z equals 1. The semicircle is going to touch that. The semicircle should also... It should go from... the other end should be at 0. Because it starts at z equals -1. Or one of the endpoints is at z equals -1. I don't know, dude. I think I'm gonna give up on this one. I'm really lost on this now. I feel like I was crushing it. It's been an hour and 35 minutes. This is just algebra too. This is the worst part. It should be a semicircle. I'm assuming I should be getting a semicircle that's infinite like that. Well, how does that work? Yeah. Because a finite shape that passes through a singularity should become an infinite shape? I'm not getting that. And why is it in the lower half plane? We can make a stab at W2. It'd be fun if this is right. What about W2 is just equal to negative W? Wouldn't that take care of it? If it is strictly in the lower half plane, just doing negative should put it in the upper half plane. It's going to reflect it horizontally too, but that, you know, we didn't say that. We didn't say we can't do that. Is U like the issue? Like, I feel like U shouldn't always be 0. That's the thing that's really screwing me up here. Is there a 0 over 0 situation happening here? Potentially? When is the denominator equal to 0? At theta equals 0. Yeah, theta equals 0 is an issue here, right? If theta equals 0 in the numerator, what happens? We still get 0. Okay. So okay. We have one more try here. Oh, I don't want to L'Hospitals this though. That's disgusting. I think we're gonna L'Hospitals this thing. Okay, the 1 goes away. Minus cosine squared. Frickin', that'll become a plus. 2 sine theta cosine theta. Minus, hey, 2 sine theta cosine theta. Two cosine theta minus 1 minus sine theta plus 2 sine theta cosine theta. Okay, so do we have 0 on the bottom here? We have 0 on top. This is 0. That is 0. Ugh. Bruh. Boxers, briefs. I'm a boxer brief kind of dude. I think I just can't simplify the numerator. Okay, so I assume I can't. Whereas I shouldn't. We do get minus 2 sine theta cosine theta plus 2 sine theta cosine theta, so that's nice. It's a good thing. 2 sine theta. Oh, these sneaky bastards. No, this is just 0. Well, wait, oh, that was Dr. Cook. I thought that was color code for some reason. Hey, Cook. No, we still get 0. Okay, this is the boring answer. I give up. We were told there wouldn't be any conformal mapping on the final, so I'm not going to stress about not getting this one, I guess. And there's time to study. It's not until Monday. All right, let's check the answer key. Help is now allowed. Okay, part 1. So the real part, e to the... I spent so long on the conformal mapping when I already forgot what I did for this question. Okay, yeah, that line matches what I have. Really? So did they give us a power series and then not use a power series? Is that what you're telling me? Oh, never mind. They use the power series later. Okay. I did it in a different order, but I got I equals 2 pi. I did it in 2 different ways that are both, I think, valid. So I'm saying 1a is a W. Let's look at 1b. Okay, sorry, so the integral is proper. Saying the imaginary part or the principal value of that. That's how I started. Jordan's lemma for the function satisfies that. Residue in the upper half plane plus residue at 0. So we end up with pi 1 minus 1 over e. Survey says pi times 1 minus 1 over e. Okay. 1b is a W. Um, 2a. For real part of s greater than 1. So ooh, wait, did I make a sign mistake? No, I did not. I just wrote it differently. Okay. I stopped at this step, but I'm not wrong. If they would mark me wrong for not going to the next step, then fuck them. No, I've never beaten a Resident Evil game. I've started. Ooh, I forget. I've started the one in Africa. I mean, maybe that's 5. And I've started another one. I should have it in my Steam. Oh, I've started on the original Resident Evil 4. I have 10 hours in it. At some point, I just stopped though. I don't have the remake and I haven't played it. The last thing I remember is like a short little dude inside of a castle, like taunting you as you're making your way through the castle. Alpha greater than 1 for t less than 0 close to the right in a large semicircle using Jordan's lemma. Okay, I did this part right. T greater than 0 close to the left in a large semicircle using Jordan's lemma. So we don't have to care about this restriction on S. I don't know. Like, it feels kind of weird to me, but I'll take it. Okay, I think I did this right. Now for this one. Where did I go wrong? It's mapped into it. Oh, I was misremembering. Circles don't get mapped to circles if they pass through the singularity. Bruh. circular arc in the z-plane is mapped into the positive imaginary axis. What did I say? I don't think I said anything definitively on that. Oh wait, well I kind of did get that. Because I got at one endpoint it's infinity and the other endpoint I got that it's 0. That was like the last thing that I did. So I kind of did. I didn't really say it. Surrounding the x-axis and the z-link is the positive real axis. Oh no, I did get that wrong. I said it started at -2. The point z equals 0 becomes w equals 1. Wait, what? Oh, okay. They're just testing points here. They're not actually doing any math. Like, come on. The interior of the semicircular disk in the z-plane becomes the first quadrant in the w-plane. Huh. So it maps a semicircle into a quadrant of the plane. Oh, and so I misinterpreted this part of the question. So I'm gonna say W2 should equal W squared. Yeah, look at that. Okay, so I was that's stupid. Like in the homework and in class, we were doing stuff like I was doing and actually parameterizing stuff. They're just doing test points. Linux physics, are you supposed to write an essay on how you feel about this? I'm tempted to write an essay on how I feel about this. For sure. I'm not supposed to, though. I'm sure the professor would love to hear my opinion on this. In lieu of an answer. Okay, well, I'm calling Balderdash. Well, I'm not. I believe the answer, but I feel like this is the cheese method of getting it. Like if you're stuck on a boss in Dark Souls, you look up methods to cheese the boss if you can't beat it the right way. And I feel like this is the equivalent of that in math. It's a lot easier, but like, come on. Okay. I think that's going to be it for me. How many points would I have gotten? If I got a 0 on that, but 100 on the others. They don't say any points for... Okay, 2 is not worth any points, apparently. You don't get points for doing 2. It's just for fun. 20 points, 40 points for 1. Okay, well, I don't know. Trying not to in 9 Souls until after beating them. That's fair, Obi. 9 Souls looks really cool. I watched you play it a bit. I mean, I have cheese boss in Dark Souls before. I'm not above it, but I feel you just need to be real about what you're doing. The non-boss I'm fighting right now is really testing my patience. Yeah, that's fair. It's important for her final exams to have fun. That's very true, Fizzbuzz. That's why they make these final exams, so the students can enjoy themselves. The good news about the final exam is that it's only 30% of your grade, which that sounds like a lot, but if the other 70% is homework, and I've done very well in the homework. I've only missed a handful of points in total. And so I already have... Well, okay, the professor did say we have already locked in a passing grade. I don't know what counts as passing. But I don't have to do that well in the final to get a good grade. I don't think. Also, keep in mind when I face the final boss in Nine Souls. The enemy wants to keep walking into a wall. That's its own fault. You know, I like your attitude, Peach Tea. Okay, I think this is gonna be it for me. I need to get food and I need to work on code for my other classes. I think so. The UW has a weird numerical grading system that I still don't understand. But there's like a minimum, like you need to get like a 3.2 out of 4, I think, to have satisfactory progression, something like that. I can find out the exact value at some point. For now I want to eat though. Be maybe 85%. Okay, that's not bad. That means that if the final is worth 30%, I would need to do like slightly better than half credit. We'll see, I guess. So yeah, I guess I'm gonna cut the YouTube stream off here, and then on Twitch we'll look for a raid. So anyone's here on YouTube, thank you for being here. I don't know when we'll be back, but we'll be back next, but we will be back.